All right. Well, good morning, everyone. It is 9 o'clock, it looks like. So I think we'll go ahead and get this thing started. My name is Charles Phillips. I'm the training manager here for Lochinvar. I've been asked by Gail Johnson, who is our regional sales manager. Gail, I believe you're on. Say hello.
Hello.
And asked by Gail Johnson through our rep Bimco if we could come on and do a little webinar for you guys today. Specifically, we're going to be looking at our residential condensing products, which would be our Knight boiler family and the Noble boiler family. So we'll be talking specifically about installation topics and some of the smart system control platform. Talk a little bit about that. Now, to be honest with you, we've got 3 hours is what we're scheduled, 9 to 12. To be honest with you, installation, if we were to do a super deep dive into that, is a half-day minimum discussion. And smart system would be very similar to that. So because of our time, I'm going to go through this pretty quickly, but I'm going to focus on some key things where we kind of run into some of the issues at. I am recording
Hey,
this.
Charles.
Yes.
Are you there? Can you hear me?
Yes,
This is
I can.
Nathan. I wanted to say good morning real quick to everybody. I'm with Vemco here in Billings. It was asked if we could just allow a couple more minutes. I just want to make sure that we got everybody on. We're going to do a little bit of a roll call. It looks like Northwest Pipe Billings is on. Looks like Vemco Missoula is on, where we're hosting the Northwest Pipe Missoula branch. Who else have we got? It looked like we were looking for Great Falls, Butte. Let me see who else we have here. Maybe Kalispell.
Yeah, I
Want
see
to look
Kobe.
through the names here if you don't mind.
Yeah, I've got Kobe is hosting Butte. He's just typed in, so add it in.
Okay, got it. I was just looking for a couple more here, Charles, if you don't mind. Okay, we got Belgrade. Let's give it a couple more minutes. Charles, and I just want to also say thanks for taking time to put this training on for us as well. We get a lot of support from everybody that's attending this in our territory, and there's times where a little bit more training, more so from the factory level, is very much appreciated, just because you guys know a little bit more tips and tricks. So we're excited.
All right, cool. No problem. No problem at all. Just let me know when
All
you
right,
want.
I'm gonna mute, and then if we could just kick off, let's say maybe 8:05. Allow just a couple more minutes.
Okay. I forgot you guys are an hour behind me, so sorry.
No problem. All righty. Thanks again. Look
All
forward to it.
Takes us a little bit more to wake up out here.
Just a little bit, huh?
Yeah, I know Nate's usually not out of bed till like noon, so.
That's not true.
I know, but it's fun to say.
Yeah. All right, I just got a text says green light, so take it away, Charles.
All right. Well,
and good morning to everybody again. Thanks again.
Okay. All right. So we'll go ahead and I'll just start over again. So just in case for everybody that didn't catch me before, like I said, my name is Charles Phillips. I'm the training manager for Lochinvar. I've been with Lochinvar for 33 years. I started my time in service. So basically I kind of worked my way up within the organization from service to training. I've been to a lot of job sites, talked to a lot of people, so I kind of know what's going on out in the field. So, but as I mentioned, Gail Johnson, who is our regional sales manager out in that territory, has asked through Vemco if we could come on and talk about our residential products, specifically the Knights and the Nobles, in regards to installation and some of the smart system topics. So like I said, we got 3 hours is what it's scheduled for. To do really deep dives into both of those topics is minimum half days each. So I'm going to go through this pretty quickly, kind of hit the high points. If you've got questions, please chat those in. It'll probably be the easiest. I'll keep an eye on that and I'll answer those. And if we need to get a little bit deeper discussion, then we can unmute at that point and get into that discussion. I am recording this, and this recording will be made available to Vimco once it's done, and I'll make it available to Gail. So if anybody wants it afterwards, more than happy to have access to it. It's not going to be a big deal. All right. So hopefully everybody can see my screen. I'm going to assume everybody can. So I'm going to see if I can get this thing to work here correctly. If I can get my mouse to work. There we go. So as I mentioned, we're talking residential products, specifically the Knight family and the Nobles. So this will be the Knight floor mount and wall mount models and the Noble products. And we just introduced the Noble floor mount model. Basically the same thing as the wall mount. It's just getting setting on the floor will be the really only difference with the product itself. With the Knights, if you're not familiar with it, just kind of briefly give you a little bit of history about this product. The Knight product family was introduced in 2005 originally. That was a water tube product. And it was also the very first product that we introduced what we call the Smart System Control Platform on. Since that point, we've gone through a few different revisions. The current product uses a fire tube heat exchanger versus the water tube heat exchanger. So we switched up designs there. We went from a 5-to-1 turn down to a 10-to-1 turn down, get a little bit higher turn down rates with the current products. And we've gone through some revisions with the Smart System Control Platform, made some improvements with that. Added more features and more capabilities into the control itself. We've also got access to or made available what we call the Connexus app feature, which is built into the control or with the control itself, which is an additional item that you can add on. So basically, we're kind of looking at our third generation of the Knight family, if you will. This product has been in production probably for about the last 5 to 6 years in its current configuration. Then you've got the Noble family, available as both a boiler and a combi. Boiler models start at 80,000 BTUs, go a little bit lower. Combi models start at 110, obviously because of that domestic side. Likewise, 10-to-1 turn down, just like we have with the Knights. Slightly different fire tube heat exchanger, so it's a different design on the inside of it. A little bit different fire tube type design, but it's still a fire tube type product. And it does have what I refer to as what we call smart control. I call it Smart System Lite. Doesn't quite have all the features that you would see on the Knight product, and that's intentional. It has quite a few features, but not the same amount that you have on the Knight. So that's kind of where the separation between the products would come in, if you will. If for some reason, I know you guys are up near the border on Canada. If you happen to go into Canada, this product is called Epic in Canada. And the reason being is because Noble was trademarked in Canada, so we couldn't use that name there. So just to give you a little FYI there, not that it really matters. So, but I'm going to start off on installation first. So we're going to talk about this topic first, and then jump into the smart system a little bit later. I'll take a break somewhere in here, probably about after we get done with installation. Probably take about a 10-minute break. Because I'll probably need to get up and get a drink of water and use the restroom. So we'll take about a 10-minute break at that point. But again, if you got questions, chat those in, type those in, and I'll try to answer those as we go along. Now, like I said earlier, I've been doing this for over 30 years. I've talked to a lot of people, been to a lot of job sites. I can tell you right now, the majority of the problems that we run into, the majority of the calls that come in, I can relate back to either installation issues or maintenance issues or a combination of both, right? Parts, pieces fail. I get that. That's just normal. Those things happen. But the majority of the problems, I'm going to relate back to an installation issue. And unfortunately, what happens a lot, and I see it more today than I used to, is people troubleshoot the symptom and not necessarily the root cause of the problem. And then you end up with a whole lot of callbacks, because you're just troubleshooting what's happening with the heater right then, but not necessarily what's creating that issue, i.e. some sort of installation issue, whether it be a venting problem, a gas supply problem, or something of that nature. And that's what we got to get down to, is get to that root cause of that particular problem. So we're going to go through this and talk about these things as we go along, all right? When it comes to the installation, I will mention this right off the bat. As long as you meet the National Fuel Gas Code requirements, I'm good. I'm generally not going to require anything more stringent than what's listed there. When it comes to gas pipe sizing, regulator sizing, venting, as long as you meet those requirements, I'm happy. Okay, and you'll see that reference throughout our manuals, throughout the manual. Must be in accordance with section blah, blah, blah. As long as you meet those, I'm good. Local codes, however, will always take precedence. And that's the kind of key thing. I'm sitting here in Lebanon, Tennessee, and I build a standard heater that meets most people's requirements. However, if you need something specific on a unit to meet a local code requirement or an insurance code requirement, we do need to know that. So that way it ships with the product, or is at least either installed on the product to begin with, or at least ships with it to be installed in the field. Some items we will allow to be added in the field, some items we don't, especially on larger commercial products like high and low gas pressure switches. We typically don't allow to be added in the field unless it's done by either a Lochinvar person or a rep who would come out and do that one. So if you've got questions as far as what you need, if there's ever any questions, check with obviously the local people, Vimco. They're going to have a much better idea as far as what you need in your area than me sitting here in Lebanon. All right, trust me, because everybody's going to be different. It would be wonderful if there was the same standard throughout the country that everybody had to follow, but that's unfortunately not the case. Everybody's going to have their own little things that they want on something. So if you don't know, check with the local guys. They're going to be able to instruct you as far as what you need on your heater to meet your code requirements. Okay. Now, the other thing I'm concerned about is this: clearances. This is a machine, and guess what machines do? They break. At some point or another, somebody's got to get in there and work on it. Now, some of you may not be involved with the installation side of it. Some of you are just dealing with service. And unfortunately, when I find those job sites where there's generally no service clearances, that means the guy that put it in is generally not the guy coming back to work on it. So he really doesn't care. So if you've got any control over the installation or any input to the guy putting it in, make sure there's room around it to work on it, because again, somebody's got to come in there. So you see recommended service clearances. When it comes to clearances, you have clearances to combustibles. Those are requirements. That's per the standard, per our test procedures that we go through. Those are requirements, and that's what's going to be listed in the manual as a requirement. You must meet this. The thing is, with high efficiency condensing products, you're talking minimal clearances, 0, 1 inch, because all your heat's going into the water, which is what you want. But it doesn't do a whole lot for service, right? Service is going to be something separate. The standard doesn't care whether you can work on something. The standard is only concerned about it from a safety standpoint. Are you going to burn a building down? So clearances to combustibles, requirements, you got to meet those. Service clearances are recommendations by every manufacturer. So this is where service and sales, sometimes we bang heads a little bit, because mechanical rooms are getting smaller, footprints more of a premium. You're trying to minimize how much room you got around the heater. So, and no offense to the sales guys in here, but they'll go in and go, hey, you got 0 side clearances. You can smack this thing between 2 wood walls, you're good to go, right? And then I come in as a service guy and go, hey, I want 5 feet around this thing, right? Because I got to come in here and work on it. So you want to get that happy medium. Now, when you see the clearances, this is for the floor mount KH, and it'll be the same thing for the Noble floor mount. You're talking 24 inches, front, left, right, top. And that's the bare minimum it would take to pull a burner, pull a control module, do certain aspects of the service on the heater itself, 24 inches. All right. That's not a lot of space when you get it right down to it. 24 inches is very, very tight. And I always like to tell people, you got to remember who's actually working on the equipment. You got to take that into consideration. Because, hey, this is America and everything's bigger than in America, even its people, trust me. All right. I fall into that category, but, you got to have the room for the guy to get in there, because if you can't get in there, it's not going to get done. I used to have a gentleman that worked for me. His name was Bob Willis. Some of you may be familiar with Bob. Bob was a little on the round side. We'll just put it that way. And Bob would always tell people you need 24 inches plus a bob, right? Because if Bob can't get in there, it ain't going to get done. And that's pretty much the truth. If the guy is there to do work on the heater and he can't get in there, it's not going to happen. So keep in mind who's actually working on it, right? So you got recommended service clearances for your floor mount models. You got similar clearances for the wall mount models. You see 24 inches at the front, left, right, top, bottom. Again, these clearance numbers are always in the manuals. So you'll see them listed in the installation manuals, and they'll also be listed on the rating plate of the heater. So you can always look at that rating plate and see what those numbers are. because clearances are important, right? And we look at the pictures here, and as we go through this, you'll see pictures of job sites, bad job sites, things that you shouldn't do. I have a large collection of this stuff. If you happen to see one of your jobs in here, I'm sorry. Yeah, it's not that I'm making fun of pointing it out, but again, if you see one of yours, it happens from time to time. But when you look at these pictures, obviously these are things you don't want to do. The unit on the, what I would say, the left side there that's in the room, if you look at that one, the front of that heater smacked right up against a wall, right? Obviously, nobody's doing any work on that one. You've got a problem there. Even if they'd spun it away from the wall, it's still stuck behind the storage tank. So that one is a big issue there. And then the one on the right, hey, we do offer products for outdoor installations. Not in Montana. I would recommend you not put them outside in Montana. I would avoid that one if all possible, but we do offer them. However, parking one between two tractor trailer rigs is probably not a great idea. Even though, yeah, they got the yellow pylons there to prevent somebody from backing over it, that's not real good from the service standpoint. So yeah, I'd kind of avoid that one if you could. Also, when you think about this, think about what it's mounted on. The pallets are real nice to move things around with, but please take it off the pallet. That would be helpful. Because that pallet will eventually start to break down and dissolve. So yeah, that's not going to be good. Also, stacking heaters, one on top of the other. We do allow that. We do have stacking frames for products, so you can mount heaters one on top of the other. Putting one directly on top of the other one, like the one on the right there, wouldn't recommend doing that either. The heater's not designed to support the weight of the other unit, okay? So kind of avoid those if you can. So I'm going to pause here for just a moment while I take a drink of water. Does anybody got any questions? If you do, please chat them in right now for me. All right, got nothing so far, so we're good to go there. So I'll keep on rolling. Now let's talk a little bit about the hydronic side of it here real quick. All right. So your flow rates through the units for the night models, your KH and your WH models. All right. I provide a Grundfos variable speed circulator with that unit as standard. You can see it there, the UP-ML model. For the smaller ones and the MXL for the larger models, I supply that as standard. All right. Now, I really don't care who you use as far as a pump. Some guys don't like Grundfos. Some guys, they like the green pumps. Some guys like the red pumps. I really don't care. It doesn't matter to me who you use. It's just as long as it provides the flow that I'm looking for. And that's kind of the key thing, right? If you want to use a standard circulator, it comes with it. Great. And realistically, we only provide that with residential products only because that's expected, right? Again, most people, they'll go with that one, but if you like something else, no problem, switch to whatever you wish. That's totally up to you, right? As long as you meet the flow, I'm good. But when we look at this table, and it shows the models on the left side, then it shows you temperature rises, 20, 25, and 35. And it shows you the flow rates that you're going to get you that delta T at a full fire condition. That's what that delta T at 20, 25, and 35 is based with the unit running at 100% of rate at that flow rate. Now, the reason we stopped at 35, 20 and 35 is kind of our normal operating range. You might be able to go up to 40, and I probably wouldn't have an issue with that. All right. So that's kind of our typical operating range. Now, the reason I don't want to see a higher delta T kind of brings me back over to that minimum flow number over there on the left, on that far right side. We'll talk about that in a second. But this is our typical normal flow rates. And you can see the flow rate per unit and what the head loss through the heat exchanger is going to be. Again, it's a fire tube heat exchanger, very minimal pressure drop through the heat exchanger, right? So I'm not dealing with a lot there. It's going to be more in the piping than anywhere else when it comes to that. But when we look on the right side, you see a maximum flow number and then you see minimum flow numbers. All right, so I'm going to talk a little bit about that maximum flow. I don't see this as big of an issue with residential products as I do the commercial products, but it is something I want to mention. The max flow number is important, right? And the reason it's important because if we exceed that maximum flow, there is that possibility that we're going to damage the heat exchanger, right? This is a fire tube heat exchanger. And what that means is basically you got a tank with a whole bunch of tubes going through the tank that your flue gases are going through, and the water is surrounding those tubes, all right? Well, your inlet connection is at the bottom of the heat exchanger. So you got a counterflow design. Burner sits at the top, flue gases go down through the tubes. Cold water comes in at the bottom and goes up. So you get a counterflow design across the tubes to pull the heat off the tubes, right? To pull the heat off, get as much efficiency out of it as you can. Now, the problem comes is if you have more flow rate than what's the heat exchanger is designed for, right? If you got a lot more flow coming into that, that flow is basically hitting those tubes at the very bottom. And what can happen over time is you get an accumulative stress on those tubes right in line with that connection, which can cause the tubes over time again to fail. It won't happen immediately. It won't happen in a month, 2 months, 3 months. It might be 2 years, 3 years, 4 years down the road, and then it happens, and then you get a stress fracture, you get a break in the tube, and then you got to replace the heat exchanger. So obviously that's not something we want to deal with. So those max flow rate numbers are kind of important. Like I said, I don't run into it as big of an issue with residential products because I generally don't have really high flow rates of residential products. It's more on the commercial side where you're talking hundreds of gallons of GPM. But again, it's just something I want to point out and say, yes, the max flow numbers is important. You want to keep that in mind. It's the min flow there on the right side that most people have the issue with. All right, so when you look at that, you got two numbers there. You have min flow at high fire, min flow at low fire. All right. Now, the control module has a safety built into it. If it sees your temperature rise across the heat exchanger from inlet to outlet exceed 50 degrees, it's going to limit your firing rate. I apologize, not 50, 55 degrees. It's going to limit your firing rate. No matter what the unit thinks it wants to do, if it sees that delta T exceed 55, it's going to say, hey, you've got a flow problem. You need to start modulating down, right? So that min flow number at high fire, that's going to give you a 55-degree delta T, all right, across that heat exchanger. So 2.1 GPM on a 55 is going to give you a 55-degree delta T. 3.2 on an 85 is going to give you a 55-degree delta T across that heat exchanger when it's running at full fire. So when it exceeds that number, that's when it starts modulating down. If it hits 60 degrees, it's going to shut off, right? So 55 to 60 is kind of a play range there. So it's going to try to modulate to keep you in there. So when you see the low fire number, and you see it's at 1 pretty much and 1.5 in the larger models, you're not going to be anywhere near 100% of rate. That's basically going to be running at min rate, and you're going to be right at that 60-degree number there to get you to that flow rate. All right. So the reason that number is there, again, is to protect the tubes. If you were to fire this unit up, for some reason, if you were to fire this unit up and there's no flow through the heat exchanger, okay, here's what's going to happen. It's going to come up to temperature real fast and it's going to hit a high limit. All right. You've got mass in the heat exchanger. You got a few gallons of water in that heat exchanger. It's not going to flash the steam. It's not going to, be hugely detrimental at that point for one time. All right. So if it happens once, no big deal. But if it happens repeatedly over and over and over, where you're firing this thing with no flow, again, over time, you're going to have an accumulative stress on the tube, which is going to cause it to burn out. Because remember, you need flow going over the tube to pull the heat off of it. Again, that's what that counterflow design is. So if the flow is stagnant in the heat exchanger and there's no flow over that tube, you're not really pulling the heat off of it or pulling as much heat off of it as you could. And again, it can cause the tube to overheat, which can cause it to fail. Again, it's not going to happen the first time it happens or the second or the third. It's going to be, the 600th time or whatever the number is, right? It's going to be way down the road that it's going to be a problem. So you got your your minimum flow rate there at high fire and low fire. Again, as long as you're above that high fire number and you're below the maximum flow number, I'm good. All right, because that's going to get you between that 20 to that 35-degree delta T. I'm kind of happy with the operation at that point. All right. So again, the standard circulator we provided will get you that number, or again, if you want to provide your own, that's totally fine, totally up to you. Don't have an issue with it. Okay. So I'll stop there for a second. Anybody got any questions on the flow rates? Max flow, min flow? I'll stop here for just a second. See if anybody's got anything. All right. Nothing popping in yet, so I'm going to assume we're good to go. All right, cool. So you're going to have similar charts for your noble boiler as well as the combi. So again, you got 20, 25, 30, 35. They actually threw a 30-degree number in there, but you'll see the max flow rate, you'll see the min flow rates. They're going to be very similar to the night numbers based upon the BTU input, because again, you're still dealing with a fire tube heat exchanger. Even though, yeah, it's a slightly different design, slightly different tubes in it, it's still a fire tube heat exchanger. It still has mass to it, so you're doing similar flow rates is what you're going to be looking at here. All right. And then you got the combi number, right? Now, the kicker with the combi is you've got an integral pump inside that heater. And that pump is kind of doing two things for you. And the primary focus for that pump is to circulate water between the boiler heat exchanger and the braze plate heat exchanger that's doing the domestic side. That's pretty much its function, and that's what it's sized for. Now, when you get a space heating call, there's a diverter valve in there that's going to switch between the braze plate heat exchanger and your system, okay? So you're kind of limited. That pump, you can't replace, you can't change it, right? You can't put a different type of pump in there. And I will tell you, I'll go ahead and mention it is a Grundfos pump. You can't change that. That pump is integral to the heater. But that also means you're kind of limited as far as how much pipe you can run with this one, right? Your night products, your KHWH, your Noble boiler, you really got a choice to do either primary, secondary piping or primary only. With the combi, because of the limitation as far as how much pipe you can run, I'll be honest with you, kind of limited to more primary, secondary than primary only, because you can look at the numbers here. So if I look at the 199 as an example, I can only run maximum of 277 feet of 1-inch pipe, equivalent feet of 1-inch pipe. And that's going to give me a 45-degree delta T across that heat exchanger at that point. So because of that, I can't really use it for a full flow system unless it's a very small loop in most cases. So most of the combis that I see installed in the field are generally going to be piped in a primary, secondary, where you've got a boiler loop with very minimal piping, and that pump then works perfectly fine. But its main function, like I said, is to circulate water between the boiler heat exchanger and the braze plate heat exchanger. That's kind of what it's looking for there. But you'll see those charts in the manual. If you want to do a primary only, that's how much pipe you can run with it. And like I said, you can't change the pump. That's the key thing. That pump is integral to the unit. All right. Now, as far as piping is concerned, like I mentioned, the two choices, primary, secondary, primary only. To be honest with you, if people ask me how they should pipe it up, I'm going to tell you primary, secondary. I'm a primary, secondary guy. That's what I like. That's what I push. Lochinvar, throughout its history, has manufactured, for the most part, low mass products, copper products, right? So water tube products, not fire tube. So very little mass within the heat exchanger. Because of that, those products, you don't have a choice. They have to be really pipe primary, secondary. So that's kind of what we've always pushed people to. So even with these fire tube type products that give you that flexibility, we're still going to try to push you to primary, secondary, because again, we supply the boiler pump, right? We give you a boiler pump on a night. That can only be used in a primary, secondary system. That's not designed to be used as a system pump in a primary only system. So you use it here in this case. So if we're doing primary, secondary piping, there's several ways to create that disconnect, right? The most common and typically what you'll see in most piping diagrams is using closely spaced tees, creating that disconnect between the boiler loop and the system loop. Closely spaced tees, a hydraulic separator, buffer tanks, anything like that can create that disconnect between the boiler loop and the system loop. And you notice I just said boiler and system, not necessarily primary, secondary. I find it amazing, depending upon where you're at in the country and how you were trained, basically. If I ask you what's the boiler or what's the primary loop and what's the secondary loop, the different responses you'll get to that. Some areas will refer to the boiler as the primary and the system as the secondary. And other areas, the system is the primary and the boiler is the secondary. And a lot of it just depends upon where you're from and again, how you were trained. Technically, both answers are correct. There's no right or wrong to that answer. When you're talking primary, secondary piping, it's just loops, right? Boiler loop, system loop, chiller loop, zone loops, it's just loops is all you're dealing with. But if you're talking to someone and you just mentioned primary, secondary, and you're thinking one way and someone else is thinking the other way, that can create a little bit of confusion, especially if you're talking a piping diagram or laying something out that could create a problem. So you do want to make sure everybody's on the right page and they understand, here's what I'm talking about. So as a rule, I'll typically just say boiler loop and system loop and just kind of leave it at that versus primary, secondary. But again, no difference between, no issues going either way with that and how you refer to it. But in this case, again, primary, secondary, closely spaced tees. I got a boiler circulator. That circulator is going to provide me the flow that I'm looking for going into the heater. The key thing where you're using closely spaced tees, and I'll make mention here, is that your system flow has to be greater than the boiler flow. Because if it's not, what can happen is between these closely spaced tees is you can get some backflow, right? Because again, that boiler circulator is sized to give you X GPM. All right, this as an example, it's moving 10 gallons a minute as an example. All right, but if your system is only moving 5, then we got a problem because that boiler wants 10, so it's going to flow backwards. So you'll create a little loop right here at the boiler. It'll get what it wants, and then your system will get what it wants. But if you're taking hot outlet water right back to the inlet, that can create some short cycling issues, create some limit issues, possibly create noise issues. So your system flow, as a rule, you generally always want to make sure it's more than what the boiler is flowing to prevent that from happening. So in some cases, a buffer tank in that application minimizes that effect, or a low loss header or hydraulic separator would minimize that because again, it adds some mass to that point at that disconnect and it kind of prevents some of that from occurring. I'll go ahead and I'll mention at this point, short cycling is one of the things that we want to avoid as much as possible. As a rule, short cycling is generally defined as more than 6 on-off cycles per hour. If you start doing the math on that, and you say figure 6 cycles an hour times 24 hours in a day, times 7 days a week, times whatever your heating season is, that's a lot of cycles. And you start getting into a lot of short cycling, that leads to a lot of premature component failures, as well as poor system efficiency. All right, the unit's not going to be as efficient if it's short cycling, it's coming on and off all the time. So you want to minimize that. I really don't want to be anywhere near 6 cycles an hour, 1 to 2 cycles an hour at most. Or better yet, if I can just get the thing to come on and just run all day long and maintain load, that's wonderful as well. If it never shuts off, that's perfect. With that said, a lot of that's going to come back to the sizing of the product, making sure it's sized correctly, the piping of the system, the flow rates, and the control side of it, which we'll talk a little bit later with the controls. There's a lot of features in the controls that we can use to fine tune the boiler to the job site. Let's just put it that way. That can basically help us solve some issues. And we'll look at the control side in a little bit and see if that will help us out. So now, primary, secondary, one option. Another option is going to be primary only. You do have this ability here. You don't have a boiler pump. You're relying on the system pumps to provide the flow that we're looking for. And hey, as long as you meet the minimum and you're between the min and max flow rate, I'm good. I don't have a problem with that. You no longer use the circulator that comes with it. You're providing your own circulators in the field at that point. So you got a choice there. I will mention with the night products, and I'm back this up one slide here. Your indirect, if you're doing indirect water heating, you've got 2 choices with this, and this is also coming into the control side. When you see it piped in this configuration, this indirect is piped in what we call a normal configuration. So that basically means it's a priority. So if you have a indirect call and a space heating call occurring at the same exact time, the indirect will be our priority. So it means it's going to provide everything to that indirect. So that's one option. The other option for that indirect is it's piped in as a zone. So the indirect can be piped as a zone. So it doesn't have, the boiler itself can be piped primary, secondary. The indirect can be piped just off the system just as a zone. When we get into the control, there's a few parameters that you have to program to tell the control how that indirect is piped in. We'll look at those in a little bit, but it's kind of important to make sure, yeah, how I pipe this thing in, I need to make sure the control is aware of that so it can control the pumps correctly at that point, provides the heat where it needs to be at when it needs it. If you're doing indirect storage tanks, all right? If you're dealing with a combi, then it's built into it. You don't have to worry about it. The only thing you have to worry about on the combi is that you got a mixing valve here, right? Yeah, there is a set point that you're programming for the combi, a set point temperature that you're programming that you want out of it. But there's always that possibility people change it. You're trying to maintain a temperature. You might get a little overage at some points that the controller is trying to respond to. So you do need that mixing valve there. It is a requirement to mix and make sure that you don't have anything excessively hot going out to the system. So that is important. So you got to have that there. Okay. So when you talk from the piping standpoint, make sure that mixing valve is installed. And I will also mention, I'll go back over here too, on these, if you're doing indirect water heating, again, you'll notice mixing valve, anti-scald valve, make sure those are installed as well. Because again, somebody can come up and change the set points on these things. And whether they intended to do it or not, they can change it. And if they do, then you end up with something really hotter in the tank, and you don't want that going out to your system. So please make sure that there are mixing valves installed on those storage tanks as well. All right. Now, something else I want to talk about is water chemistry. And before I jump into this topic, again, I'll sit here for just a moment, see if anybody's got any questions. Just go ahead and type that in if you want. I'll give it just a moment here. All right. Doesn't look like I've got anything coming in. So that means I'm doing an excellent job so far. All right. So water chemistry. Why is this important? All right. So we start talking about water chemistry. I look at fill water, makeup water, boiler water, and then I look at what's called sediment, or basically what's in your system. So from a water standpoint, there are a few things I want to look for. All right. So let's talk about fill water, makeup water to begin with, and then boiler water. When you read the manual, you'll see a chart for boiler water, you'll see a chart for fill water. The numbers are going to be different. The fill water is what we're starting with, and there are certain numbers that we're looking for that you start with. The boiler water is once you add your glycol, your inhibitors, and all your other stuff to the system. That's going to change the numbers, and I get that. So those have a separate set of numbers that we're going to be looking for. But I want you to start from a good point to begin with to make it easier to get you to the boiler water side. Because if you don't start from a good spot to begin with, that creates its own issues within the system. And then you have to do a lot of gymnastics to get you where you want to be at. So we want to start with good fill water to begin with. And we have those will be the numbers we're going to be talking about here in just a second. Then you got the filtration side of it. Basically, how do we protect the system over time, right? Again, systems, especially retrofit systems, that's been in for 10, 15, 20 years, they're dissolving. What's happening to all that stuff that's in the system? Where is it going to? We need to make sure we're protecting our heat exchanger from that. So again, how do we deal with that? So we're going to look at that filtration side here in just a little bit as well. But with the fill water, you've also got, again, the makeup water side of it. Again, things are going to happen. A valve's going to pop. Somebody's going to crack something. Something's going to occur. The key is how much fill water are you adding? Most manufacturers, as a rule, will typically tell you no more than 5% of total system volume annually or per year, right? So you want very minimal, because if you're intaking a lot of fresh water, you're bringing in a lot of air, you're bringing in a lot of fresh sediments. You're changing your boiler water numbers. The boiler chemistry side is going to be different because you're adding the fresh water. And the makeup water should be of the same quality as what the fill water was. However, that's typically not the case because most makeup water lines are coming right off the city, and it's generally nowhere near what the fill water was. But that's neither here nor there. It should be the same quality. The key thing is to watch out for makeup water. I will give you an example of a really bad job that we had. This was a few years ago. It was at a small university, and they installed it as a retrofit. So you had a central heating plant, and the piping went underground to a couple of different buildings. So they replaced the boilers that were there with 3 of our 2.5 million BTU Crest boilers, our larger, what we call flagship products, large fire tube products. So they put these things in. 6 months goes by, the first heat exchanger fails. We get it back, cut it open. There's 3 foot of scale on the bottom of the heat exchanger. All right. So it's like, where's this coming from? So we start really investigating what's going on at the job site. So we're talking to the guys there, and we're asking them, "Hey, are you having to bring in a lot of water? Are you having to bring in a lot of fresh water?" And they're like, "Yeah, we're having to intake a lot of water." So we asked the question, "Well, how much water are you bringing in?" And their response was a little shocking. They said, "Well, we're adding 150 gallons an hour." Right? Not a week, not a month, an hour. They're bringing in 150 gallons of fresh water an hour. That's no longer a boiler. That's a water heater at that point. All right. And we asked them, "So where are the leaks at?" And it was like, "Where's it going?" And they're like, "I don't know." They didn't care. They had no concern about that. So obviously that was a big issue, because now you had one heat exchanger fail. You've got 2 more sitting there that's getting ready to do the same thing. So we worked with them. We gave them a break on 3 new units, but we told them, "Hey, you got to fix your system, or otherwise it's going to happen again." So instead of fixing the leaks, ripping up the digging up the ground and fixing the leaks like they should have, they basically piped the boilers to plate and frame heat exchangers. So they isolated the boilers from the system. So the boilers to the plate frames to the system. Right? So from my standpoint, hey, fine, whatever. That's what you want to do. Good. I got no problem with that. You didn't really fix your problem. You just put a great big Band-Aid on it. But hey, the boilers are happy at that point because they're isolated from the system. They just now had to deal with the plate and frame heat exchangers, dealing with those if they fail, making sure that they're clean. So that was on them. But that was their answer to that particular problem, was to just isolate them that way. So makes it rare. I don't see it happen that often. Again, that was a huge amount of water being added to the system. But again, something you got to be aware of. If you're bringing in that kind of water, it's going to create issues with the heat exchanger. All right. Something else we're concerned about is glycol. Right. If you're in a cold climate area, adding glycol to your system is pretty much a no-brainer, right? Because that's your freeze protection. I've had guys tell me, "Well, you got freeze protection on the boiler." Yes, there's freeze protection built into the control of the boiler, but that freeze protection only works if you have power. So if you have a power outage and the boiler's been off for a week and it's -10 and there's no glycol in the system, well, guess what? You just froze a building, and somebody's going to have to deal with the effects of that once it thaws out, which is probably not going to be very good. So you need glycol. We recommend propylene glycol over ethylene. Primary reason for that, ethylene is typically a alcohol-based glycol. It will attack gaskets and seals. It can, obviously, if it leaks out and Fido drinks it, Fido dies. So we generally try to avoid that. If you wish to use ethylene, that's totally up to you. It's not going to affect the heat exchanger. Ethylene glycol will not harm the heat exchanger. It's going to be more of the system-related components that becomes an issue with. So because of that, that's why we recommend propylene. And you'll see that there is a D-rate. Anytime you add glycol to the system, there's going to be a D-rate with the system. You have to take that in mind. Generally 50%. There's really never a reason to ever go above 50%. I've had guys in classes tell me they use 100% glycol. And, and I'll ask them, why? Why do you use that much glycol? And generally the response is, that's what the owner wanted. Sometimes the owner doesn't really know what he needs. He just hears glycol prevents freezing. And so he thinks more is better. And that's not necessarily the case. Because if you add 100% glycol, you're not pumping liquid, you're pumping sludge at that point. All right. So there's not a reason for that. So if you're doing that, just talk the owners out of it. You don't need to do that. But just be aware there is a D-rate. If you want to get the D-rate back, you increase your flow rate through the heat exchanger. You can do the calculations. There's a formula for that to calculate how much flow you need to increase by to get the D-rate back on that one. So, so you can see for a 50% mix, if I increase my flow rate by 13%, I'll get my D-rate back on that one. So there is a calculation for that. Now, what are we starting with? What are our fill numbers? So when you read the manual, you'll see a table like this. And it's going to show you here are my four things that I'm looking for: hardness, pH, total dissolved solids, and chloride concentrations. So these are the four magic numbers that I'm looking for here, right? So let's talk a little bit about each of these and how it applies. So pH, first off, pH is basically a scale that shows me, is the water acidic, alkaline, or neutral? Where is it at on the scale itself at? We want to be neutral. 6.5 to 8.5 is a neutral level. If the water is less than that, then it becomes acidic. Then it's going to attack stuff. Now, realistically, your stainless steel heat exchanger, I'm not concerned about the stainless steel heat exchanger at that point. It's going to be everything else attached to it, right? Your pumps, your fittings, your piping, everything else is going to be attacked by that. If the water goes above 8.5, then you become alkaline. Now you start scaling. Then you start scaling the heat exchanger, scaling the piping, and we have other issues. So maintaining that neutral range is kind of where you want to be at. Measure the pH. If you don't know what it is, measure it. You can use a meter, you can use strips. I would not, don't use the strips. Let's just put it that way. Don't use strips. Use a meter. Don't be the pull guy, right? Come out and go, yeah, you got this number. Don't do that. If I look at that chart, between that color chart, 3 to 6 looks the same to me. I can't tell the difference in any of those, so I have no idea what that number is. So just use a meter and be done with it. If your pH is out of range, then we need to correct that. And typically, it's going to be some sort of additive, some sort of chemical that you're going to add to the system. I am not a chemical guy. All right. I'm just going to tell you right now, I'm not a chemical guy. I don't sell chemicals. Use whoever you wish to use. Some guys prefer Sentinel, some guys prefer Fernox, some guys prefer this, that. It's totally up to you. I'm sure the reps, the distributor in the area, they have brands that they offer and they sell, and they recommend. They work with them. Okay, go for that, right? I'm not that guy. If you call me and go, how much of this stuff should I add? I have no idea. I didn't make the stuff. I don't deal with it, so I'm going to refer you back to the chemical manufacturer at that point when it comes to finding out what your dosage amount needs to be for your system, right? So contact the manufacturer of that stuff. And if you call me, I don't have a clue, right? So I don't deal with the chemical side of it. Then you've got TDS. So pH is basically the acidity, alkalinity of the water. TDS is basically how much stuff do you have in the water. And to be considered totally dissolved, it has to be less than 2 microns. All right. So basically, TDS is pretty much everything that's in the water itself. Hardness is separate. Hardness is a different animal. All right. So we start talking grains of hardness. That's a different animal than what TDS is. Hardness is primarily calcium and magnesium. TDS is everything that's in the water. But again, less than 2 microns. Now, down here at the bottom, you see a little note. All right, it says too low of a TDS can result in a low water cutoff probe not registering. All right, when you measure TDS, all right, what you're measuring is the conductivity of the fluid. All right, that's what you're using this meter for. You're measuring the conductivity of the fluid. So if we go back here and we look at this little note, how does a probe style low water cutoff know that there's water in the heat exchanger? Well, it's completing a circuit path to ground through the water. It's using that conductivity to complete that circuit path with. So if I've got less than 10 parts per million in this water, if I don't have any conductivity in the water, it can't complete the circuit path. It can't work. If you come into a unit and the low water cutoff isn't working, right? If you have a probe style low water cutoff, it's not working. Quick, easy test, take the probe wire off the probe and ground the wire, right? If the low water cutoff works at that point, then you know, hey, the board is good. That means the problem is at the probe. Either the probe is calciumed over, its probe is cracked, there's no water in the heat exchanger, something of that nature, right? You know the problem is at the probe area. If you ground the probe wire and it still doesn't work, well, then you know the problem is at the board because you've completed the circuit when you ground that probe wire. You've completed that circuit. So that's a quick, easy way to test that low water cutoff, but you need at least 10 parts per million to complete that, to have enough stuff in the water for that circuit to work, right? So 10 parts per million on the bottom end. What's my top end? The top end is 350 parts per million. Once you exceed 350, then we just got too much stuff in the water. And when you start heating this water, this stuff cooks out, right? You get the precipitation of the solids coming out of the water. Then you start getting scaling within the heat exchanger. Now, you're dealing with a fire tube heat exchanger. And the problem with that is fire tube heat exchangers, because of their design, it's a tank with a bunch of tubes in it. But because it's a tank, that means you generally got lower velocities through the tank. You don't have a lot of velocity through here to create a scouring action within it. Plus, since you've got all these tubes in there, you've got all these little narrow, tight gaps, these little crevices and these little cracks that water's flowing through. Well, when this stuff starts building up around those cracks and crevices and starts filling up those gaps, then you're insulating the tube from the water, which again, then over time will create that failure point on that tube. The tube will overheat and create a failure point. So once we exceed 350, that's its own concern. So we want to make sure that we're under 350 parts per million. So there are a few different ways of doing that. The first way is demineralization of the water, and that would be the preferred method. There are different manufacturers of these types of things out there. That the rig that you see in the picture there just happens to be manufactured by Califfi, but there are different ones out there. And all you're doing is stripping the source water and you're depositing that stuff into the medium that's in this device. So your cold water comes in at the bottom. You've got a pad at the top. You program that for whatever level that you want out of it, and it keeps the water in there for a period of time as it strips that stuff out of the water itself and deposits into the medium. So that's the preferred method. You do have a couple other options, and that is reverse osmosis, and you also have distillation. The problem with both of those, especially RO, is it makes the water very, very, very pure. All right. So that gives you two issues. One, very pure water, you got no conductivity through it. So that means your low water cutoff isn't going to work. Your other issue, very pure water, is also very aggressive water. Water is looking to achieve an equilibrium. It wants to get back what it lost. So it's going to start leaching minerals out of whatever it comes in contact with to replace what it's lost. So again, your stainless steel heat exchanger, you're probably going to be all right for the most part. It's going to be everything else it comes in contact with, right? Your piping, which in a lot of cases could be either black iron or copper, your pumps, your fittings, all that other stuff is going to be attacked, and you're going to create failure points. You're going to create leaks in the system. So that's what you're trying to avoid. We had an unfortunate situation with a guy who he kind of went from one extreme to another. As a residential application, his system was old, put the boiler in, plugged it up within a few months, right? Because he didn't clean the system, didn't do what he needed to do. So he went from that extreme to the other. He cleaned the system out and then filled it full of RO. He filled it with reverse osmosis water, thinking he was being good, right? He's thinking, hey, I'm putting very pure water in this system. It's going to protect the system and all that. Well, unfortunately, it created the same problem, just differently. It now attacked the system. It ate it out, basically, and still plugged it up. So he went from, like I said, one extreme to another with that. So again, you're trying to find that medium, making sure that we're below 350, but above 10 to make sure that everything works properly in that case. All right. And then you've got your hardness, right? Grains per gallon. If you've been in this business long enough, we've all cracked pipes that look like that, right? I always like to joke with people that don't know any better and tell them, hey, that's what you're drinking. That's where kidney stones come from, right? When they see that picture. And it's always amazing. They go, really? And I go, no, that's not where it comes from. But they don't know any different, right? So you're looking for a certain amount of hardness in the water, 5 to 12 grains, because again, if you go below 5, that's when you start bottoming out 0. That's when your water gets very pure and becomes aggressive at that point. But anything above 12, then we just got too much stuff in the water, right? Too much hardness in the water. Again, as you start cooking that stuff out, it's going to start filling up the gaps and crevices and creates the blockages in the heat exchanger. Now, as I mentioned earlier, there is a difference between TDS and hardness. TDS is everything that's in the water less than 2 microns. Hardness is primarily calcium and magnesium. That's going to be the real difference. A TDS meter does not measure hardness. It's a separate thing because, again, the TDS meter is just measuring conductivity. So you do have to take a water sample, all right, and basically send that off for most points, most of the time, to get that analyzed to tell you what it's going to be. Now, we offer water test kits. So we've partnered with a company So we can provide a water test kit. There's a fee for it, but basically it's cost. So you could buy the kit, take the water sample, send it off to this company, and they would give you a third-party test report as far as what your water is and tell you everything that's in it. So we do offer that as a service. We do offer that. So that is something that is available. But you want to check the water and see where we're at. If the water is in excess of 12 grains, then we need to soften it, treat the water. Most water softeners typically are going to be sodium based. So if you're dealing with a sodium based softener, just remember that's going to increase your TDSs. So you're going to have to deal with that on the back end. There are a lot of newer systems. They're typically, you're talking ion exchange, template assisted crystallization or TAC systems. So there are newer systems on the market that don't use sodium, but they're going to be a little bit more expensive, obviously. So it depends upon what you want to go with there at that point. That's totally up to you. All right. And then the last item here, real quick, as far as the four big ones we were looking at, is what's referred to as chlorides. All right, chlorine, everybody knows chlorine. Chlorine's added to potable water for sanitation purposes, right? It's added to that. So when you're pulling your water in, you're going to have a certain amount of chloride in it, or chlorines in it. Our concern is that it's not excessive, all right? If you exceed 150 parts per million of chlorides in the water, that can strip the passivization layer off the stainless steel. All right, so stainless steel, we all know, has basically a barrier on it, on the metal, that protects the metal. All right, and that's called a passivization layer. When you weld on stainless steel, it damages that layer and then makes the underlying metal susceptible to corrosion, right? So you got to make sure that passivization layer is there. Now, the passivization layer over time, when you weld on a pipe, basically will over time heal, if you will. That's kind of a generic term, but it basically heal. What we're concerned about is if you're exceeding the 150 parts per million, then it can actually strip that layer off. And if you strip the layer off, then the tube itself becomes susceptible at that point. That's what we want to try to avoid. All right. So we're concerned about that. So if you've got over 150 parts per million, just make sure that you're dealing with some sort of citric acid or some sort of carbon filtration system, making sure that we're protecting the tubes themselves. All right. So those are the four big numbers, right? Your hardness, your TDS, pH, chloride. So as long as we meet these four numbers, then I'm going to be good. All right. So let's talk about the older systems, the retrofit systems, the sediment, the stuff that's been dissolving in your system. Now, and you can correct me if I'm wrong here, right? In a retrofit system, right? Here's what happens, right? You basically cut the old boiler out, or I should say you drain the system, you cut the old boiler out, you clean and flush the system, you pipe the new boiler in, and you fill it full of clean, fresh water, right? That's what happens. Of course it is. That's what we like to say, tell people, but it's not really what happens. We know what happens. They valve the old boiler off, cut it out, slap the new one in, turn it back on, and all that stuff that's been dissolving for 20 years goes right into that brand new heat exchanger. And we have a problem. The majority of the stuff that ends up in your system is what's referred to as iron oxide or magnetite. All right. I have a great example I use here in the classroom here at our office. Basically a big black jug of water basically that you pull from a system that's full of this iron oxide. So that's your concern, because if that gets into your heat exchanger, again, with fire tube heat exchangers, it will start plugging those points up. Water tube heat exchangers have an advantage. Water tube heat exchangers, by their nature, you generally got higher velocities through those tubes. The tubes are much bigger. So you don't have the spots for this stuff to collect. Again, fire tube heat exchangers, because of their design, again, those small, tight, narrow passageways, the crevices that this stuff can collect in, this is where it becomes more of a concern. So we've got to deal with the sediment, the stuff that's dissolving in your system or flaking off in your system, from getting into the heat exchanger. So what kind of filtration systems can we put in place? As an absolute bare minimum, you're talking a Y strainer, right? With a number 20 mesh. Now, these things, whatever, no matter what system we use, whether it be a Y strainer or some other system, will only be as good as the guy doing the maintenance on these systems, right? So a Y strainer, and the big problem with the Y strainer, and most of you have probably seen it, you walk into a mechanical room, you look over in the corner, or if you look up on the pipes above the Y strainer, you'll see a whole bunch of these little mesh screens, right? And the odds of a mesh screen being inside that strainer at that particular moment are probably going to be pretty slim, right? Because what ends up happening, they plug up, you've got no flow, guy comes in, changes out the strainer, a little bit later, it plugs up again. Guy gets tired of changing out the strainer, he just leaves it out. Invariably, that's what always happens. All right. So that's kind of the issue with the Y strainer. Again, it's only going to be as good as the guy doing the maintenance on it. But again, the Y strainer for number 20 mesh is only going to really catch the big stuff. That small, microscopic stuff, the magnetite, is generally not going to get caught up here a lot. It's going to make its way in. So we need something a little bit better. Right? So this is where the dirt mag strainers come into play at. And there are a lot of different ones out there, it's totally up to you, but this is what we would recommend be installed in front of the product. It would be a dirt mag strainer. And again, it's only going to be as good as the guy doing the maintenance on it. Now, where dirt mag strainers really came into popularity was because of the pump guys, right? When the pump guys, 15 years ago came out with the variable speed pumps, well, they found a problem real fast because what's in a variable speed pump? Magnets. And those magnets have a tendency to attract this stuff, right? So what ended up happening is these pumps would get installed and just a few months later, they'd fail. So the pump guys would get it back, trying to figure out what's going on, and they would see that the rotors are basically plugged up just like that one in the center. So it causes the pump to fail. So the pump guys realized this, they went back, changed their designs, hardened their pumps a little bit to prevent that from happening. Now it still occurs, but it's not as bad as it used to be for the pumps. Now, the boiler guys are sitting here going, well, that's interesting because if your pumps are in front of our boilers, your pumps are having this issue, it means our boilers are having the same issue. So it's a concern to us as well. So that's why we're recommending the dirt mag strainers get installed and added to the systems to prevent this from going into the heat exchangers. So that's the next method. Another option is sidearm filters, and I like sidearm filters. Those are working very, very well. As long as the pumps are moving, you're circulating that fluid through the medium, pulls that stuff out, works very good. But again, no matter what system you choose, no matter what filter you put on it, it's only going to be as good as the guy doing the maintenance. And if they're not cleaning these things regularly on an old system, it's not helping you. And that's the truth. Somebody's got to go in there and clean it. We like to tell people to protect the investment. All right. Here's the thing. I'm not talking to the owner. You are, right? So I don't see the owner. I don't talk to the owner. You guys are. I don't give these boilers away. You guys don't give the boilers away, right? So we've got to get to the owner to get them to realize, hey, there are certain things we need to do to ensure that the boiler lives a long, healthy life, right? I get it. Owners are cheap. They don't want to pay for maintenance. They don't want to pay for things, but you got to express to them. If we don't deal with the system, the boiler's going to fail. All right. And it's that pay me now or pay me later proposition, right? Or pay somebody else later proposition, right? Because you stick this thing in, they don't treat the water, they don't deal with the water, and the unit fails in a year or 2 years, okay? It leaves a bad taste in the owner's mouth. He's going, well, I don't want that piece of crap Lochinvar because it failed in 2 years. I want something else. They put something else in and they don't deal with the water. Guess what? In another 1 or 2 years, they're going to have the same problem again. So it's all about making sure that they protect that investment. So I've got a question here. So I'm going to go ahead and stop for just a second from Wes. So he says, I've had a PG supplier suggest up to a 50% glycol mix with DI or demineralized water. It appears from your slide that DI water isn't suggested. That would be straight deionized water. Okay. If you're adding I'm assuming PG, I'm assuming you're talking about propylene glycol, that's going to change everything at that point. So if you were just running a straight DI water, that would be a concern. I wouldn't recommend it because it's going to be very aggressive at that point. So that hopefully answers your question. So again, if you want to use it, just be aware that if you're mixing it, it is changing the characteristics of that water. So yeah, I'd rather not use deionized water, reverse osmosis. I'd rather not use it if it's just gonna be a straight water system. But if you're going to use it as if you're going to use it in a mix, then you're probably going to be all right with it. Just make sure that the numbers are good, right? Because again, the eye water is going to be very, very aggressive. It's going to be very pure. So that's going to be your concern. So, all right. So hopefully that answers your question. If not, just reply back, let me know, and we'll go from there. Okay. If you got a follow-up question on that, if you wish, right? So so Wes, if you got anything else you want to add to that, please do so. Hopefully that answers your question for you. All right. So again, like I said, get with the owners and tell them we got to deal with this system. Right. Otherwise, they're going to end up with problems. Okay. So I'm going to wait there for just a second. I'm going to get a drink of water, see if anybody's got any other questions. All right, looks like everybody's good. But again, if you got questions, just add on, type them in, let me know, and we'll go from there. All right. So now we'll talk a little bit about venting, get into this venting topic here real fast. So to be honest with you, venting is one of those areas that should have the most attention paid to, right? Venting is that one area that you really need to make sure it's done correctly, because if the vent system is wrong, if the venting's done wrong, you can end up killing somebody, right? And obviously that's the extreme, but unfortunately it happens every day in this country. People die from carbon monoxide poisoning daily in this country from bad vent systems. You may not hear about it because it doesn't happen in your area, but trust me, it happens daily. So you want to make sure that vent system is done correct. And here's the kicker. If, even if you didn't install the job, so maybe you just show up on a job, and if you notice the vent system is wrong, it is incumbent upon you at that point to make somebody aware of it, to get the system corrected. Because if you don't, and something unfortunate happens, guess who's going to be named in that lawsuit, right? Because you were there, you will be named in it, you saw it, and you didn't do anything. You don't need that. I don't need that. So if you see something wrong, make sure people are made aware so that way it can be corrected up, right? Because when you start talking venting, there are a lot of different ways to look at vent systems and how you do it and how you achieve it. A lot of different materials that can be used. Again, here's the thing. If you follow the guidelines in our manual, or any manufacturer's manual, I'll say this, if you follow the guidelines in any manufacturer's manual, you'll probably be okay. All right. It's when people will start deviating from the manual. Yeah, I know the book says you can go 100 feet, but I need to go 130 feet. I know the book says this, but I need to do this. That's when people start running into the issues, right? Now, we might have a little leeway based on what you're doing. If we know what you're doing, we might be able to give you some suggestions and help you out a little bit. But as a rule, we're going to go by what's in the book, right? So if you start deviating from that, all bets are off at that point, okay? Now, with that said, rule number one, when it comes to venting, vent it outside the building, all right? Like I said, I get a lot of bad job site pictures. And amazingly, the great majority of them are vent systems. I get a ton of bad vent system pictures all the time, which is totally amazing, but we do. This one is an old picture. This happens to be an atmospheric water heater. This was at a dairy barn in Fort Worth, Texas, years ago. And as you can see, they stuck a 3-foot section of pipe on it and a vent cap for some reason. I don't know why. But you can see the discoloration that's occurred on the jack. You can see what's happened to the heater. Obviously, again, I can laugh about this job because I know nobody died here. Unfortunately, I do have those pictures where people have died because of stuff like this, because somebody said or thought, hey, this is good, we can do this, and they let it ride. And obviously that is a dangerous situation. That's what we want to avoid at all costs. All right. Now, as far as venting guidelines, some of the stuff we want to watch out for, with these units, you can go up to 100 equivalent length of pipe. All right, with certain sizes, we'll look at the tables here in just a second, but up to a maximum of 100 equivalent length of pipe. 90-degree elbows are 5 feet, 45-degree elbows are 3 feet. Now here's the kicker. I know that if you look at a 2-inch, 3-inch, 4-inch PVC pipe, the numbers are different. What the equivalent lengths are going to be different based on what size you're dealing with, right? For our purposes, all right, no matter the size, 2, 3, 4, doesn't matter. It's 5 feet for a 90. 3 feet, 445. That's how we're doing our calculation. Okay. So yeah, I get it. For different sizes, it's going to be a different number, but for our purposes, 5 and 3 is going to be the number, right? So maximum of 100 equivalent length of pipe, minimum of 12 feet on the vent side, just to put a little bit of back pressure against the unit itself, against the blower to make it work correctly. That's what I'm looking for there, all right? As far as your sizes are concerned, you'll notice that your 55 through your 110 nights, you got a choice to do either 2 or 3 inches. The 3 inches would be what would get you up to 100 feet. That's going to be the standard to get you to 100 feet. If you reduce it to 2 inches, and we allow you to reduce it to 2 on those models, you will get a corresponding drop in length. And you see it there, it goes 80, 50, 40, right? So you got to keep that in mind. The 150, 85, 199, you don't get a choice, it's 3 inches only. And the 285 gives you the choice of either 3 or 4. And likewise, you're going to have a corresponding drop in length. For your Noble models, same thing. You get 100 feet for the 80 through 110 for 2 inch or 3 inch. Either way, you're good there. It's the 150 that gives you the D rate. The 199, you can't do the 2 inch. So again, as long as you're within that equivalent length, I'm happy. For the materials themselves, for the air inlet pipe, it's an air inlet pipe. It's an air inlet pipe. I really don't care. PVC, CPVC, poly, I don't care what you use. Galvanized, single wall, double wall, doesn't care. It's an air intake pipe. The only thing I'm concerned about is that it's sealed airtight. If it's not sealed airtight, then the heater is going to be subjected to whatever's going on in the mechanical room. If the room goes negative, it affects the heater. If there's chemicals in the room, it affects the heater. So because of that, that kind of limits you. If you have to make sure that pipe is sealed, it's going to limit you primarily to the plastic stuff, which I don't necessarily have an issue with. All right. For your vent side, you got choices: PVC, CPVC, poly, stainless, AL294C. That's your choice at that point. Some areas of the country will not allow PVC. They only allow CPVC, so it does depend upon your area and your jurisdiction where you're at. So you may have an issue there. But with the materials, if you're using PVC and CPVC, keep in mind how you're joining that. You got the primer and then you got the other stuff. And generically, I always ask this in the class, what do you call the other stuff? And invariably it always comes up, it's glue, right? Everybody calls it a glue. It's not a glue, it's a solvent, it's a cement. It's chemically bonding the two pipes together, and that is important because if you don't do that properly, that can create leak points. And unfortunately, not to say that any of you guys would do this, but there are a lot of guys that don't know any better out there. They will take that glue and just basically seal up around all the pipes, right? I've seen guys dry fit pipes together and then use the glue to go around all the seams. Okay, that works for a little bit because once that heater cycles a few times, that expansion and contraction takes place, all that pipe's going to fall off. And the heater has no idea that that's happened. So you've got to be aware of that. Again, like I said, I know you guys wouldn't do that. You know better, but there are guys out there that don't. And those are the guys that we're worried about. So keep in mind what that stuff is actually doing. The better option for me would be poly. I like poly. Poly, it was designed as a vent material. That's its sole purpose. That's what it was designed for. It's much lighter. It's easier to work with. Yes, it's probably a little bit more expensive depending upon the size that you're talking about. But I'd rather use poly than the PVC or the CPVC. If I've got a choice, that's what I would recommend. Okay, or better yet, even that, go stainless steel, the AL294C, either single or double, right? I would recommend the double because it's prettier, it looks better, and I don't have to buy it, right? That's the other thing. So you can use that as you wish, right? Whatever you do, do not mix and match materials. If you start with one, stick with the other. That picture there, I don't think that rubber fern coat is going to last very long, nor is that galvanized pipe going to last very long on a condensing unit. So that's going to eat up very, very quickly. So make sure you use the appropriate materials throughout. As far as your terminations, vertical termination, sidewall termination, you also have a concentric option as well. So you can do some different things there. I'm not going to spend a lot of time here on the termination points. These are all in the manual. And a lot of that is basically making sure that the vent is above the air intake, right? Trying to minimize recirculation of flue gases between the vent and the air intake is what you're trying to do. And a lot of these clearances are straight out of the National Fuel Gas Code. So it's not necessarily Lochinvar or some other manufacturer specific. It's per the code. So as long as you follow those guidelines, again, you're going to be all right with it. Like I said, you can do either single vent air intake through the roof, or you can do a concentric combined vent air intake out through the roof with a single penetration. You've got that option. If you go sidewall, you have the snorkel method, or some people refer to that as the gonzo method. You can do that one. Again, maintain your clearances there. This is a great picture here. Yeah, I've got my clearance between the vent and the air intake, but obviously that air intake down here at the bottom, that's going to be a problem, especially in areas that have a lot of snow. That's going to basically create a blockage there and seal that off. So it's going to be an issue when you look at that one. And then you've got this optional sidewall cap. This used to come standard, but we realized most people never used it. So it was kind of pointless. So we basically made it optional. It's a flat plate. Combines both the vent and air intake, but you still got 2 penetrations through the wall. It looks good. You can paint it to whatever color you want. But again, most people typically, if they go sidewall, generally do the snorkel method and leave it at that. That's not an approved option. The dead birds are a nice touch. I'll give them that. That looks pretty good. But the big issues there are how close it is to that L-shaped corner and then how close it is to the overhang. Because the one thing that you're trying to minimize is getting flue gas for circulation. And in those 2 areas, those flue gases are going to have a tendency to kind of hang right there because of that overhang creating a rollback and because of that L-shaped corner creating that swirling wind effect cause those flue gases to hang right in that area. A lot of times with your termination points, the main thing you want to ask yourself is where I put these caps at, is there a possibility these flue gases are going to get hung in this area? And if they can, that's probably not a good spot for them. Now, you're probably going to get a little bit of recirculation no matter what on every install. The kick area is going to be to make sure that it's not doing it constantly all the time, every time it comes on. That's what generally kills the heater. So this would be a bad location because it's pretty much going to happen every time this thing fires up. So watching your location is going to be kind of critical. Dead birds are a nice touch though. I'll give them kudos for that one. Again, concentric going out of sidewall, that's good. That's probably not a great location for it. Because you got multiple things there. You got the window, you got the door, you got the dryer hood, and you can see all the lint down here at the bottom. Down here at the bottom. The question is how much of that's now been sucked up, sucked up into that air intake. And the other thing is, with these 2 caps here, they can argue about which one came first, but I can guarantee you that hose bib came with a building. All right, and hose bibs are designed to do what? That's right. They're designed to drain. And when they drain in that location, it's going to drain right back into that air intake. And if they didn't orient the air intake correctly, that means it's running right back into the blower, which is going to create a problem. So something just to be aware of. All right. Document and correct any faults, right? Whether you installed it or not, if you go on a job site and you see something that's wrong, again, whether you put it in or not, you got to let somebody know about it, right? Put it in writing, let the owner know, let the rep know, let us know. You don't want to be the bad guy. You don't want to piss the owner off. I get that. I'll do that. Give me a call. If you see something that's wrong, that's going to kill somebody, we need to be made aware of that so we can get in there and shut it down at that point. If you want to be making an anonymous phone call to the fire department, I smell gas in this building. Guess what? They'll come out and shut it down real fast. Okay. Trust me. It's amazing how quickly they show up when you mention gas. All right. So make sure that they're aware of it. That's a great picture. It's not even my heater, but that's a really great picture with a retrofit there with that tankless replacing that tank type water heater. And that unit ran until that P-trap filled with water, and then they had a problem. So that's a really great picture. Again, you can call us. There's an 800 number on all the products. Or you can send us an email to tech@lochinvar.com. Again, if you see something wrong, make sure that we are aware of it. Okay. Now, gas supply real quickly, and then we will take a break here in just a couple of minutes. Gas lines, as long as they're sized per the National Fuel Gas Code, again, I'm happy. There's going to be a table in the manual. That table is going to basically show you pressure and volume, what we're looking for. Make sure it's sized correctly. There is a little note there about flex lines. I've had people tell me, well, I've heard, you can't use flex lines on Lochinvar. Yes, you can. I don't have a problem using a flex line as long as it's sized right. The problem people have with flex lines is they use the sizing table that's in the manual, which is for black iron hard pipe, and they use that for the flex line. Those are 2 different tables. So make sure that you're using the right table for the pipe that you're using. If you're using a flex line, make sure you're using the manufacturer's table for that. As long as you size it right, I don't have a problem with using it. But again, I've had that comment come up, and the reason it comes up is because they put a flex line on a heater. They had an issue with it because it was undersized, because they didn't size it right. So as long as you size it right, I'm good. Now, if for some reason you're dealing with a high pressure system, that's fine. I mean, a lot of systems are going to be pound systems. That's perfectly fine. Couple things about a pound system is one, there's going to be a step down regulator involved. Typically multiple step down regulators, typically one for each appliance in most cases. Kicker is make sure it's a lockup regulator, cannot exceed 14 inches coming into the heater. Make sure that the regulator is located 10 to 15 feet upstream from the appliance. Or I should say 10 feet upstream of the appliance. I, I, I will tell you, the bigger the appliance, the more critical that becomes, right? If you're talking a 55,000 BTU heater, you come to my factory, you go into my lab, you'll see these heaters sitting there and that regulator's 3 or 4 feet away. Not a big deal, right? You get to about 1 million BTUs, 2 million, 3 million, 5 million, you better have 10 feet between that regulator and that heater, or you will have a problem. It won't be if, you will have a problem. I'll guarantee it. Because then you're going to have regulators hunting on one another. That high pressure regulator and the low pressure regulator in the appliance will hunt on one another, and you will have all kinds of issues from a combustion standpoint. You'll have pulsing, you'll have noise, you'll have hard starts, you'll have flame failures, you'll have all kinds of problems. So that number becomes critical. So we'll tell you 10 feet of pipe, straight pipe, not fittings, 10 feet of actual straight pipe between the high pressure regulator and the appliance to give you the volume that you need there to prevent that from occurring. All right. But again, just keep in mind, if you're talking 80, 100,000, yeah, it's probably, you can probably get by with a couple of feet, 3 or 4 feet. But again, when you get to the bigger models, yeah, it's a must. And if you're dealing with propane, I'm sorry, I hate propane with a passion, but it's one of those necessary evils, right? Because not everybody has access to natural gas. So you got to have a propane system. The kicker with propane, you're still dealing with the same stuff, right? You're still dealing with regulator sizing, you're still dealing with pipe sizing. But the other thing that you've got sitting there that you got to deal with is that propane tank. I don't size propane tanks. I can do the math. Yeah, I can do the calculations. I can calculate what you need, but I generally don't size them. I'm more refer you back to the propane supplier. Now, if you force it, I'm going to ask you 2 questions. How much money you got and how much space you got? Because you'll get the biggest freaking tank that you can get shoved in there, right? Because the bigger the tank, the more vaporization you have off the tank surface. That's why propane tanks like this are going to be horizontal, right? I'm not talking about the 100-pound cylinders or the 20-pound cylinders. I'm talking about tanks. They're horizontal because you're dealing with the surface area, all right? So when you start talking surface area, then you start talking fill level. You never fill the tank completely because you got to have that surface area at the top, so they generally get no more than 80%. But your greatest vaporization capability is going to be at 50% fill because that's your largest surface area in the tank. So how much propane do you have in the tank? How big is the tank, and what is your vaporization capability off that surface? Those are all things that we have to look at when we're sizing propane tanks. And then sizing and dealing with propane tanks. The other thing is, how low do you let it go before you fill it? As a general rule, 25%, 30%, somewhere in that range. I've had guys tell me, hey, they let them go down to 5. Okay, they're braver than me, especially on older propane tanks, because where's all the crap at? And the bottom of the tank. So you let it go that low, there is a distinct possibility you're pulling up a bunch of crap. So don't let it go that low. 25 to 30% is probably a good number before you fill it back up again, right? And then as far as the numbers are concerned, what are my pressures? Right? Everything that we manufacture is rated for low pressure, 14 inches water column or less. So every chart that we provide is going to be based upon 14 inches water column or less, right? Your minimum numbers, 4 inches for natural gas, 8 inches for propane. That minimum numbers for the purpose of outlet adjustment. Now, when we're measuring this, if you call the factory, all right, there's a couple of warnings here. When you call the factory and you say, hey, I've got this unit and I'm having hard starts, I'm having flame failures, I'm having whatever problems, combustion related. One of the questions that you're going to be asked is, what is your gas supply pressure with the unit setting off? And then what happens when it fires and runs, right? Static and load. That's the number I'm looking for. Now, if your response to that question is it's good, take a guess where we're stopping at. Right there. Like I said, if you call me and I ask you that and you tell me it's good, we're not going any further. I've spent way too many years talking to way too many people going, oh yeah, gas is fine, gas is fine, gas is fine, to find out they got a gas problem. All right. So I need to know static and I need to load load. If you come back and tell me it was 12 inches with the heater off and it's 12 inches when it fires up, That tells me you either didn't check it, okay, or you didn't check it while it was running. Because I don't care how good the gas supply is, there should be some kind of drop there, right? Between static and load. You should see some kind of drop, right? Now, how much pressure drop is good? Well, I will tell you between 1 to 2 inches, right? As a typical rule, 1 to 2 inch drop between static and load, that's normal. And that's typical. That's what I would see. It's when you start seeing 5, 4, 5, 6 inch swings between static and load that you've got a problem, right? Because remember, you're talking regulation on the inside of the heater. You got typically a low pressure regulator in most cases. It sees 14 inches coming in, and all of a sudden it sees 6 on a natural gas unit. Yeah, you're still above the 4-inch number, but you got a big swing right there. That low pressure regulator is trying to compensate. It's trying to move. Sometimes it makes it, sometimes it doesn't. And you end up with hard starts. You end up with flame failure. You end up with issues. So if you start seeing large swings between static and load, and you're dealing with combustion problems, that's where I'm focusing in at. You have a volume problem, either pipe sizing, regulator sizing, something there is creating a volume issue. You shouldn't have that big of a drop, right? 1 to 2 inches, like I said, maximum between static and load. And then again, never pressure test the line with anything more than 14 inches with the heater connected. That's the problem. Most of the time when you're pressure testing a new gas line, it's generally what? 5 pounds, 10 pounds, 20 pounds, whatever the number is, right? I've heard a lot of different numbers. They're always going to be greater than 14 inches. Make sure the heater is not connected to the line when you do that. Otherwise, you'll be buying a gas valve. Because if you hit the heater with more than 14 inches, hit that gas valve with more than 14 inches, you've basically blown the seats out of it, and you will be buying a new gas valve. So don't do that. Okay. If your gas cock is taking a pee, you have a problem, right? That's not good. Because now you're not only replacing the gas valve, but you're also replacing all the piping in that line. Unfortunately, I've seen this happen a lot. I've actually seen it happen with guys actually hooking a water line to a gas line. And that was a huge mess at that point. So this one just happened to be the guy just have to let the unit outside, and it rained, and the rainwater flowed down into the gas line. So, but yeah, if that happens, you've got an issue. So be aware. All right. Electrically, hey, you got a 120 volt supply to the heater. Pretty much anything under 2 million BTUs that we manufacture is going to be rated for 120. So you got a 120 volt connection that comes in, and then you've got your pump contacts. And again, we can control boiler pump, system pump, and a DSW pump. Now, boiler pump, DSW pump, most of the time we use those a lot. Very rarely do we see the system pump being used. We can control it if you want. It's totally up to you. But here, I'm going to be powering those pumps up. All right. Power directly. Now, we're talking very minimal amp draw here. There is a 5 amp fuse that's protecting those 3 circuits. So you can't draw more than 5 amps on any given circuit here at this point. Otherwise, it's going to pop the fuse. So if you're putting bigger pumps on here that's going to draw more than that, you're going to need to take my 120 and power up an external relay, and then use those contacts to power up your pump, right? For our larger commercial products, that's what we would do. We'd give you a set of dry contacts there, and you basically run your power through at that point to power up your pump that way. So in this case, again, you're only good for 5 amps, so make sure that your pump's not going to draw more than that. Otherwise, you're going to have a problem. On the left side of the panels where your knockouts are going to be at, for the floor mount model, the wall mount model is going to be on the bottom side or the underneath. And you have connections for your main power as well as your low voltage connections going to the low voltage terminal board. For your Noble, kind of the same thing, Noble boiler. I control power coming in, and then I've got power going out to DSW boiler and system pumps. For the Combi, because again, the boiler pump is internal. I'm controlling that. That's already wired. You do not have to worry about that one. The system pump, we can control if you wish. It's totally up to you. But again, most people typically won't control that one, but you have that option if you wish. Okay. Making sure that the power is wired correctly. You've got proper grounding on it. You're dealing with a DC flame rectification system. If your ground is not good, you're going to have a problem. All right. So you need to make sure you got a solid ground path on this unit to make it work correctly. Otherwise, you'll deal with flame signal losses, flame failures, things of that nature. So make sure the grounding is good. Make sure the polarity is proper, right? Black is hot, white's neutral. Now, if you reverse that, or if there's a lot of voltage on the neutral leg, that will drive the module nuts. It will cause it to do weird things. So make sure that the neutral leg is neutral, that there's no voltage on it. Yeah, you'll probably see a couple of tenths of a volt, no big deal, but just make sure there's not like 5 volts or 10 volts there. That can be a problem. So make sure the neutral leg is good and make sure your ground is good at that point. And also, if I happen to walk into your facility and I see something like that, I will be leaving. I will not be troubleshooting that, okay? There's nothing more than I hate than a rat's nest of wires and a control panel. And I really hate it when a guy uses the same color for everything and I got to trace it all down, right? At least this guy was decent. You know, hey, he put some notes over on the wall to help you out if you want to troubleshoot it. And he was equal opportunity. He's got a couple of different manufacturers in there from the zone valve standpoint, so you can do some different stuff there. But yeah, if I walk into that, I'm probably just going to leave. So just to give you a FYI there. That's totally up to you. All right, so that was a very fast run through of install. Like I said, we could do a super deep dive and we can get into a lot more detail, but we really don't have that kind of time because I need to get into the smart system section. But I'm gonna stop here for a second, see if there's any questions. In fact, I'll tell you what, here's a good stopping point. It is 9:30, 10:30 here. So we've been going at this for about an hour and a half now, so it's pretty good time. I'm gonna take a quick 10-minute break. So right now I've got 10:31 on my clock. I'm gonna take it. I'm actually do a 9-minute break. So I'm gonna come back. Let's come back at 10:40. So if you've got questions, type those into the chat and I'll answer those when we get back. But let's take a quick break to about 10:40, okay? And I will see you in a little bit. All right, guys, we'll go ahead and get back started at it. It is 9:40 your time, 10:40 my time, and I've got a lot more to cover, so we'll go ahead and jump back in. Looking at the chat box, doesn't look like anybody's had any questions. So I'm assuming that's good. Hopefully that's good. Hopefully I'm doing a great job of explaining all this. So, but again, if you got questions, just type those in and we'll go from there. All right. So now we're going to switch gears. We're going to jump into the controls section, right? What we refer to the smart system control platform. And we'll look at the night first, and then we'll look at the key things with the combi. Because a lot of the noble parameters are going to be the same parameters that we have with the night. When you get right down to it, there's a couple that's going to be a little bit different. And we'll hit those as we go along. But so we'll focus on the night and then go from there. As I mentioned earlier, we do a deep dive into this. We're talking multiple hours to go to this control system, so we don't have that kind of time. So I'm going to go through this and just kind of hit some of the key parameters. That I feel are going to be the main things that you're going to be playing with, and then some of the navigation as far as how we go through it. But again, if you got questions, please type those in and we'll go from there. Okay. So when you first power this thing up, you're going to see the setup wizard. That's going to be the first thing that pops up when you get there. That's going to allow you to program some of the more common things that you can see there: time and date, space heating, DSW, ramp delay, things of that nature. Some guys use this, some guys don't. It's totally up to you. If you don't want to use it, the setup wizard, just hit save when you on the control, and basically it'll just take you right out of that. If you want to program through it, just you see where it says next. This unit uses what we refer to as the navigation dial, or the knob on the front of the display, to basically move you through screens and to make adjustments. That dial also has a push button component to it. So when you see that where it says next and it has the down arrow, that means you're just pushing that dial in to move you to the next thing. Then you also got what's called multi-function keys. So there's a left and right key that you can press on either side of the display that do different things as well. So right now, the left one would say save. So if you just want to bypass this, hit save and go on to the next thing, right? But if you do that, what's going to happen is you'll see this one here, you'll say unloading or uploading parameters. That's uploading to the control itself. But let's actually get into the controls. So let's do this. First things first, most of the parameters, not all, but most parameters require you to enter a password or a passcode. I don't know why we call it word, it's actually a code. Require you to enter a passcode. So to get to that, thing isn't moving here, you're going to hold the menu select button for 5 seconds. All right. And when you do that, it's going to bring up, it'll say password. And it's basically 4 digits that you're going to enter from left to right. And it's a code, it's not a word, it's 5309. And you're going to use your dial to adjust the first one to 5, press the dial in, moves you to the second one, gives you to 3, press the third, then press the dial in again, gives you to 0, and then 9 is the last one. So 5309, you're going to hit save. When you do that, that will give you access to the parameters. Now here's the kicker. That passcode is not adjustable. It's fixed. You cannot change it. All right. People ask all the time, why can't you make that a changeable? Why can't we adjust that? And here's why. If you go online right now and Google Lochinvar password, you'll get 1 million hits on it. It is not a secret. It is out there. Right. So then people go, well, that makes it all the more important to make it changeable. Well, here's the problem with make it changeable. If you make it adjustable and someone comes in and changes it and they leave and don't write it down for anybody, right, then you get on the job site, well, guess what? You can't get into anything. So then you've got to call the factory and go, hey, somebody changed the passcode. I don't know what it is. I need to change it. So that means I've got to give you a backdoor code to be able to get in and change it. Well, as soon as I give somebody that backdoor code, guess what's going to happen? It ends up on the internet. That's what's going to happen. So our philosophy, our thought process was, why go through the hassle, right? You leave it at 5309 and be done with it. And that's the same passcode for everything that we build. It's 5309. Now, most guys, if they're bound and determined to screw with something, they'll figure out your word or your code. They'll play around with it. They'll figure it out. Most people, especially homeowners, in most cases won't have the gumption to go and do that. So they might try something once or twice and then just give up on it. But again, it's not a secret. They can find it if they go online and hit Google, they can find out what that code is. So, but once you put that in and hit save, allows us to go to the next thing. Oops, here we go. So we're going to start looking at some of these menus, right? And there's a large selection of menus that you're going to go through with a lot of parameters under each menu. Like I said, I'm not going to go through all these. I'm just going to hit some of the key ones. So the first one's going to be under temperature settings. So when you select temperature settings and access that parameter, for whatever reason, I can't get this thing to move forward here. There we go. I'm going to see all the adjustable parameters under that menu. All right, so first one, and I kind of hate how they set this up. All right, when you look at these units for the nights, you have 3 different temperature inputs you can program: system heat 1, system heat 2, system heat 3. And they can all be programmed at different temperatures. All right, now the temperature settings and the high limits can be accessed by anybody without a passcode. I'll show you how to do that a little bit later. But let's just say I come in and set a set point of, let's say I'm going to throw a number, 120. I set a set point of set point 120. I don't want anybody to change that. That's where this min and max set point come into play at, right? That's going to limit what somebody can adjust the parameter to if they don't come in here and change it. So if I set my set point at 120 and I don't want somebody to play with that, I can set the min at 120 and the max at 120. Guess what? He can't adjust it. If he's outside the parameter list, if he's just accessing the parameter without the code, and again, that can be done, and I'll show you how to do that. He won't be able to make an adjustment outside of this range. He would have to actually input the 5309, come to these parameters, and spread those back out again. Most of the time, they're never going to do that. They'll never realize it's there, right? Because they don't go that deep with it. But if you want to prevent somebody from doing that, that's how you would do it. Now, the problem with it is, whatever the min and max numbers are, that applies to each of your temperature inputs, 1, 2, and 3. So if I say, all right, set point 1 is going to be 120, and I set min and max at 119 and 121, I won't be able to set point 2 any differently. It'll have to be within that range. So if they're going to be different temperatures spread out, that min and max is also going to have to be spread out, okay? So that covers the min and max. That's just basically going to prevent somebody from changing the set points without the passcode, all right? So let's talk about these set points. What are they? If you are not doing outdoor reset, that means you do not have the outdoor air sensor connected to the unit, and you're just going to run a straight set point temperature. This is the target number. This is your set point that you're trying to achieve at either the outlet sensor or the system sensor if you have it connected. Right, if you connect the system sensor to the unit, it's going to look at that. That's what that's your controlling sensor is going to be, the system sensor. For a single unit application, you don't have to use a system sensor. I would recommend it, but you don't have to. For a multiple unit cascaded system, which we'll talk about in a moment, you have to use a system sensor for the cascade to work correctly. Right, and I'll explain why later. But if it's a single heater, you can use the outlet, it's perfectly fine. But in this case, this is what you're trying to achieve. Let's say at that outlet sensor would be, in this case, 165. The numbers that you see on the screen here are not the default numbers. These are just numbers that were in the control when we took the picture. So that's not your default number. So don't get hung up and say, no, these are my defaults. No, the defaults are in the manual that would come with the heater itself. All right. So let's say I set point 1 at 120. All right. That's what I'm wanting to achieve at the outlet. Okay. If you're going to use outdoor resets, right? If you have an outdoor sensor connected to your unit, okay, that number, the set point number, becomes the top end of the reset curve, right? So that's kind of the important thing. If my outdoor reset curve needs to hit 180 degrees, that number, your set point, has to be 180. If you set it to anything less than that, it will limit what the reset curve will do. Again, when we get into the outdoor reset, we'll talk a little bit more about this, but that's important. If you're doing outdoor reset, if you're using that outdoor air sensor on the unit, this number, the set point, has to be whatever the top end of that reset curve is going to be. Otherwise, it will limit it. Okay, write that down, keep that in mind. This is what's happening here. If we're not doing outdoor reset, it becomes the target number. This becomes what you're trying to achieve. All right. So let's just assume I'm not doing outdoor reset. This is the number I'm trying to achieve. 120. I'm gonna put a number out. We'll leave it at this. We'll leave it at 165. How's that? That makes it easy. Okay. 165 is my number. Okay. Now, the next two numbers down beneath this affect that, and that's going to be your offset and your differential. right? So your set point, your offset, your differential, or making up your modulation, if you will, all right? And this is in my first line of defense when it comes to short cycling. All right, so offset is how many degrees above the set point will I allow the unit to modulate and run to, right? So in this case, the default is actually 10 degrees, right? As it leaves the factory, the default for the offset would be 10 degrees. So that means if I've got a set point of 165, that means the heater can run to 175 before it would shut off on temperature. Now, whatever stat you've got tied in could shut the heater off well before this, but if I'm allowing the heater to cycle off on temperature, it will not shut down until you got to 175. All right, so between 165 and 175 is where I'm modulating at. All right, because again, that set point, whatever that set point number is, that's my target. That's what I'm trying to achieve. So the control and its logic is going to say, I need to get to that set point as quickly as possible. And that's what it's going to try to drive to. It's going to run at 100% to get you to that target number. Right? If left to its own devices, unless you tell it otherwise, that's what it's going to do. It's going to run at 100% to get you to the set point. Once you get to the set point, then it's going to start modulating down to keep you at that set point, right? So it wants to stay at that set point number no matter what. So if you start going above it, that's when your modulation kicks in and starts modulating down. Now, I'm going to allow, in this case, 10 degrees before I actually shut the unit off on temperature. So what I'm assuming is by the time I got to 175, the heater is running at 10% rate. It can't go any lower, right? So that's what I'm trying to achieve here. Now, the differential number, all right? The differential number is when the heater kicks back on. The differential is how many degrees does it have to drop from the offset before it responds to a call for heat. Now, as it leaves the factory, the number is going to be 20. The default on that number would be 20. So in our example here, set point of 165, offset of 10. That means the unit shut off at 175. If I have a differential of 20, where is it coming back on at? We do the math. 175, subtract 20 from it, 155. That's where the heater would initiate a call for heat. Right? If your thermostat's calling for heat, that's when the heater would be allowed to come back on, is when it dropped to 155. So it hits 155, the heater says, come back on, unit fires back up. Now, since I'm below set point, the heater's going to ramp. Again, if you don't tell it to do anything else, it's going to go to 100% rate to get you back to target. So when we start talking short cycling, this is my first line of defense as far as how I can minimize that. I can spread that offset and that differential further apart to give me longer run times and longer off times and allow that to see if I can respond and satisfy or prevent some of the short cycling, right? Now, in the example that you see on the screen here, offset of 10, differential of 4, that's a problem. Here's why, all right? Set point of 165, offset of 10, it shuts off at 175, all right? Somebody sets the differential at 4. Well, if I subtract 4 from 175, you get 171. Well, guess what? You're still above set point. The heater will never come on. It will say set point met in the display. It's got to drop below the set point before it would respond to a call for heat. So setting it at 4 is pointless. It will never come back on at that point. So your differential has always got to be greater than the offset. Otherwise, it will never come on. So, and again, the more range that we can spread between those 2 points, the less cycling we're going to get. It's going to minimize the short cycling or minimize the cycling of the heater, because again, it's going to run longer on the top end. And when it does shut off, it's going to stay off longer on the back end before it comes back on again. So again, if we can spread those numbers out, instead of 10, we go to 15, instead of 20, we go to 30. Again, if it drops 30 degrees in the system, is it really that noticeable? In most systems, probably not. So we can spread those numbers out a little bit more and see where we get our performance at. Okay. So that's what offset and differential are doing for me. That first line of defense there. We have other features that we can use, and we'll talk about those when it comes to cycling as well. If this doesn't work, we have some other things that we can apply, but that's going to be the first thing I want to look at, is spread those numbers out a little bit and see what happens, right? So we got system heat 1, set point offset differential. You have system heat 2, set point, offset, and differential. And then you've also got system heat 3, offset, and differential, right? So again, you got 3 different temperature inputs, 3 different offsets, 3 different differentials, right? And again, whether you're using all 3 or whether you're just using one, it's totally up to you. It's however you wish to control it at that point. The last item there, it says 3-way valve time. Just ignore that one. We used to offer a multi-level temperature control. We no longer offer that. And basically that control would control mixing valves. So if you're using all 3 different temperature inputs and you're running at different temperatures, the unit would always run at the hottest set point if they were all calling. So you had to protect the lower temperature zones, or you have to protect the lower temperature zones. So that device would control a mixing valve. Today, like I said, you use some other mixing control device, Tecmar, some other manufacturer at that point could supply that. But again, key thing, and I'll make this point, if you're using all 3 different temperature inputs, whichever one has the highest set point, when that calls, that's what it's going to drive to. So if all 3 are calling, and say you got 120, 140, and 180, if all 3 are calling, it's going to go to 180. So you do have to protect those lower temperature zones. So you will need some sort of mixing control at that point out there to control those lower temperature zones. So keep that in mind, all right? All right, next set of parameters I want to look at is what's called the functions menu. So when you click on that one, that brings up a few different parameters. First one there is service mode delay. So the Knights, or all these products, have what's called a service mode feature. Basically allows us to come in from a service standpoint and override whatever's going on, right? I can come in, push a button, bring the heater on, allow the heater to fire and run up to 100% rate. Now, the delay there is if you activate service mode and just leave, in 10 minutes, it's going to time out and go back to normal operation. When you're in service mode, all your safeties are still active. So your high limits, your temperature protection, all that's still active. So if you hit any safety, it's going to shut the heater down. But if you just walk off and it's running, in 10 minutes, it's going to time out. Now, anytime you interact with the control, it's going to reset the timer. Right? So if you push a button, twist the dial, whatever, it does reset the timer. So that 10 minutes will start over again. If you don't want 10 minutes, you want 5 minutes, you can set it to whatever number you want at that point, right? But 10 minutes is the maximum that it will go to. So you can't go anything above that on this particular unit. Now, you've also got freeze protection here. All right, so the first level there is kicking the boiler pump on. So if the inlet temperature, and it's looking at the inlet temperature here, hits 45 degrees, it will start the pump, the boiler pump and the system pump. It will energize those contacts. Whether you're using the pump, whether you're using them or not, it's going to energize those contacts, all right, when it hits 45 degrees. Now, once it goes above 45 degrees, then it kicks the pumps off. It turns those contacts off at that point, but 45 is my number there. Now, you got this other one here that says freeze burner on. If the inlet temperature continues to drop, and it drops to 37 degrees, it will actually fire the burner and run it at min rate. It will run it at 10% of rate. All right. Now, the problem with that is if you get a snow melt system, and we've run into this issue, you have a snow melt system and sometimes those temperatures drop, you'll get that phone call. Hey, why is my unit running at min rate for? There's no call. The snow melt system's not calling. Why is it running? Well, that's because your temperatures dropped this low. So you can't bypass the feature. You can't turn the feature off. Freeze protection is always on. You can set it down to like negative 20 degrees for the pump kicking on as well as the burner kicking on. You can't turn it off, but you can set it really, really, really low, which hopefully should get it out of the way. But just keep in mind that it's going to be there. It's going to be active. Now, the last one there, freeze burn differential. If your burner does fire and it's running, it's got to increase your inlet temperature that many degrees. So in this case, it kicked the burner on at 37. It's got to raise it 5 degrees before it shuts it off. So that means it's got to bring it up to 32 degrees before it would shut the burner off. But again, all of those numbers are adjustable there. And you got a pretty wide range. Like I said, I think the bottom end's like negative 20, 25. Top end is like 140. It goes up pretty high. There's really no reason to take it up any higher than that. So, but I mean, 45 and 37 are good numbers there. But that's the freeze protection and that service mode delay. All right. Now, next set of parameters I want to talk about, whoops, here we go, are the DHW settings. So if you're doing indirect water heating can be initiated one of two ways, either with a tank sensor or a tank thermostat. Use the tank sensor. Do not use a thermostat. Yes, I know I allow you to do it, but don't use a thermostat. Use a sensor for a couple of reasons. One, using the sensor gives you access to some more parameters, some more adjustments to be able to fine tune it a little bit better. It also gives you a little bit better sensitivity, a little bit better control over what you're maintaining in your indirect storage tank. Also, with tank thermostats, I have seen in the field tank thermostats, depending upon their sensitivity, create issues where they start to basically flutter. The contacts start to flutter as you get near the set point. If those contacts start fluttering and you're bouncing 24 volts to the control module, that will cause the module to basically start, stop, start, stop, start, stop, which will cause that fan to ramp up, down, up, down, up, down, up, down, which can in turn create fan speed lockout issues. So don't use the stat, use a sensor, right? We supply a sensor with the tank, use the sensor, hook it up, you're going to get better performance out of it. So if you're using a tank sensor, you have your tank set point. What temperature do you want to store in your storage tank? That's going to be the number I'm looking for there, right? 110, 120, whatever the number is, that's the temperature I want in the storage tank. Your tank set point differential is how many degrees does the temperature in the tank have to drop before it comes on, before it initiates that call for heat. For water heaters, 4 to 6, for an indirect water heater, a 4 to 6 degree differential is typical. And that's what I would keep you in at. I don't like seeing 1 or 2 degrees on a differential like that, because that has a tendency to cycle too much, right? It's pretty easy to drop a degree. So I'd rather keep it between the 4 and 6 number is a good range, right? As far as the differential goes. But that's, again, how many degrees it's got to drop below the set point before it initiates the call. Now, once the boiler fires, then it's going to try to achieve at its outlet sensor your DHW boiler set point, that third parameter. What water temperature do I want coming out of the boiler going to that indirect coil? Typically, the hotter the better, right? That's why that's 180. So generally 180 degrees is what I want going to that coil to get quicker recovery, quicker satisfaction of the storage tank, right? To get that temperature back up. Now, if you want to run it at a lower temperature, you want to run 160, 150, 140, again, as long as it's above whatever the tank temperature is, you're going to get heat transfer. It's just going to take longer to heat the tank up, right? Or if you size it that way, in some cases, I've seen people size their coils or size their plate frame heat exchangers or their brace plates to run at 140 degree boiler side, just because they want to maintain that higher efficiency, right? Which is fine. This depends on how you want to size it. But again, this is what the temperature is going to be leaving the boiler, going to that indirect to satisfy that demand, okay? Now, it has its own offset and differential that you got to deal with, right? So again, remember, offset, how many degrees above the set point we're going to run. Here, it's 5 and 10. Remember, on the boiler side, it was 10 and 20. Here, it's 5 and 10 for a couple of reasons. One, all right, offset of 5, that means the boiler is going to run till it hits 185 on the discharge, all right? The boiler, if it sees 185 degree on the outlet temperature, will force the modulation down no matter what. All right, so it will create a conflict. If I set that offset at 10, then it's going to try to get to 190. The control won't allow it to do that, right? Because it's going to force the modulation down once it gets above 185 anyway. So it creates a conflict within the control. So your offset's going to be at 5 there. So it gets you to 185 on the discharge before it shuts off. 10 degrees on the differential. That means it's coming back on at 175. The reason we keep that a little bit tighter is because, again, you're doing indirect water heating. What's the one call we don't want to get from people? I'm running out of hot water, right? So I want that to be able to respond a little bit faster than I do on the space heating side. Again, if you drop 30 degrees in the system, you're probably not noticing that in the air in the room. But on the water side, your potable side, yeah, people will probably notice it when the temperature starts dropping too much. So you don't want that complaint. So we're going to keep those numbers a little bit tighter there. 5 and 10 would be the defaults. But again, if you want to play with those numbers, that's totally up to you. But to be honest with you, most people generally don't. All right. Your next two numbers there, circ pump offset, circ pump differential. we will give you the ability to control a building recirc line. All right, so if you want to control a building recirc pump through our control, you will have to put a sensor out in that loop, and we have to program up these numbers to basically start and stop that pump based on temperature. I don't know if I've ever seen anybody use that parameter, just to be honest. I don't know if I've ever seen anybody use that one. And the reason being because if there are recirc lines, typically they're either wired to run continuous or they have a thermostat on them controlling the building recirc line, building recirc pump. So I've never seen that done in the field with this one. I give you the choice. If you wish to use it, that's fine. So this, so you have the offset and the differential there that you'd have to program, and that's going to be based off the take temperature going out to the system at that point. So when it kicks the pump on, when it kicks off. So again, totally up to you if you wish to use that one. All right, so boiler offset, boiler differential. Now you got on this next screen here, you got this says tank min set point, tank max set point. Again, the tank set point is a parameter that's accessible without a passcode. So again, you want to prevent the owner from changing that. You got that set at 120. Min's at 120, max is at 120. He cannot adjust that parameter. He's limited. So again, that's a choice if you want to prevent them from doing that. So again, he'd have to come here and change it if he wanted to. The next one is DHW max fan speed. All right, so in a lot of cases with the boilers, your boiler's the size for the heating load, and you might have a small indirect, maybe a 30, 40, whatever the indirect size is. In some cases, the boiler is too much for the coil. The output of the boiler is too much for the coil, and you're going to end up with a lot of cycling issues, your limit issues, things of that nature. So the DHW max fan speed allows me to basically derate the boiler when we're in an indirect call. So I can control the fan speed, which in turn controls the firing rate of the heater. So depending upon the model of the unit will dictate what that max fan speed is, what it can go to at 100% rate. So depending upon, say, if it can go up to 7,600 RPM at 100%, well, if I set that down at, say, 4,000 RPM, well, that gets me down to probably about the, 55% range, right? Somewhere 55 to 60% range. If I want to go a little more, we can do the calculations and figure out what that number is going to be. But this just allows me to quickly, easily derate the boiler when we get that indirect call. So now I can better match up the load, all right, the indirect load to what the boiler is to prevent the short cycling, to prevent the kicking on and off, or to prevent the limit issues. Very useful parameter that you have there. So if you're doing indirect water heating, in most cases, you're probably going to have to limit it down. And you just got to figure out what RPM do we need to be at top end to satisfy my demand, all right? And then underneath that, you have DHW type, all right? With DHW type, you've got two choices. So you've got what's referred to as the normal configuration, and then you have the zone configuration. So again, when we looked at the piping earlier, we saw the normal configuration. The normal was with the indirect pipe right off the boiler. Okay? In that configuration, it's going to be one or the other. I will satisfy either the indirect demand or the space heating demand. The indirect will have a priority. So if they're both calling at the same time, or if let's just say the space heating's running and I get an indirect demand, I'm going to switch over to indirect because that's the priority. But when you do that, I've got these other two parameters here that pop up, the switching time parameter, all right? So when I switch over to the indirect, I'm going to start that DHW to space heating switching time. That's 30 minutes as it leaves the factory. So that means I'm going to stay in indirect mode for 30 minutes. At the end of that 30 minutes, if I still have a space heating call, I'm going to switch over to space heating for 30 minutes. And then I'm going to start that space heating to domestic switching time. And I will stay there for 30 minutes. And after the end of that 30 minutes, if I still have an indirect demand, I'm going to switch back. You will switch back every 30 minutes until you satisfy one or the other demands, and then you'll stick with the other one. Now, here's the kicker with those times, all right? If I go into domestic, right, and I'm sitting there and I'm running for that 30-minute time limit, okay? And then I switch over to space heating. Well, again, I size my space heating to run for long periods of time. I want that space heating to run for a long period of time. I don't really want to satisfy that space heating demand. I want to keep it running, meeting load, and running at low firing rates. The problem is, if I'm in space heating, I'm not satisfying the domestic. Well, the problem is then your tank's getting cold and people are going to start complaining. So typically what you're going to do with these two timers is you're going to spread the one time out, the DHW to space heating. You're going to increase that time. That can go up to, I think it's 40 minutes. You can crank that up you can crank it up a little bit further. You can go up to about 40 minutes on that one. So you'll spread that out longer. And then when it switches over to space heating, I can crank that one down. I can set that one down to maybe 1 or 2 minutes. All right. So I can do either or. All right. Now, if you just want to stay in indirect mode, you don't want to switch, all right, set them both to 0. You set them both to 0, it will stay in indirect mode only once it gets a call. And it will stay there until it satisfies it before it switches back. So you can do that. It depends upon how you want to control it, right? It's totally up to you. But just be aware, if you do switch to space heating, it's going to stay there for that time frame until you satisfy that demand or that time frame expires, which means your indirect's probably going to get cold. All right. Your other option there is the DHW type zone. That means your indirect is treated as a zone. It's just another high temp loop at that point. And there I've got to figure out how I'm controlling the system pump. And this is where we would really want to control the system pump, right? Because then I got to tell it, when I get that indirect call, do I force the system pump on or do I block the system pump? All right, because if I have it as a zone, do I need that system pump running to get fluid or get hot water out to that zone, right? So I need to force it on. If it's, say, during the summer, right? You know, I'm in warm weather shutdown. If I've got an outdoor reset on it, right? If it's in warm weather shutdown, I need to force that system pump on. All right. Or do I need to block the system pump? Maybe I'm running low temp zones and I've got this one set at 180. So I want to force that system pump off. I don't want that 180-degree water going out to those other zones. So how you want to control that system pump. So again, it's totally up to you. Now, to be honest, generally the only time I see the zone configuration is if you're doing a multiple unit cascade. If we're doing a multiple unit cascade, I treat the indirect as a zone, then any boiler in the cascade can satisfy that heat demand. If you treat it as a normal and, you know, hey, that one unit fails for whatever reason, well, then you're out of hot water at that point too. So if it's a multiple unit cascade, that's generally where I'll see it treated as a zone. Otherwise, it's typically going to be in a normal configuration. Right. So I'm going to stop there for just a second. Does anybody have any questions? I'll give you a moment to see if you got anything you need to type in here while I get a drink of water. All right, checking the chat box. Everything's still looking good. Nobody got any questions? All right, well, we'll keep on going then. All right, so your next set of parameters we're going to look at is going to be your outdoor reset. If you hook up the outdoor sensor to the unit, you hook it up to that low voltage terminal board, the outdoor reset parameters become active. That means the control will be looking at these parameters and it will be looking to calculate your reset or calculate your set point based on the curve, right? So when we look at these parameters, you're going to have 4 parameters that make up the curve. Outdoor low, outdoor high, set point low, set point high. All right, so these 4 parameters make up your curve. So outdoor low, all right, and again, you have outdoor reset for each heat demand, 1, 2, and 3. So like you had set points for 1, 2, and 3, you also got an outdoor reset curve for 1, 2, and 3. So you got to program this for each of them if you're using all 3. But outdoor low is your design outside air temperature. What is the coldest outside air temperature you're going to get to? All right, so what's your design day, right? Depending upon where you're at in the country, we'll change that, right? Here in Middle Tennessee, your design day is probably 35 degrees, right? That's probably what you're going to see. If you're in Juneau, Alaska, it's like minus 40. Okay, so that depends upon where you're at in the country, is dictate what that number is. But the outdoor low is what is your design day, right? Outdoor high is the starting point of the reset curve. At what temperature, what outside of temperature do I need to start changing my set point? Again, that's the start point of the curve, okay? So those are air temperatures, right? Design outside air temperature, the coldest day, and again, the starting point of the curve. That's the 2 things I need to know. The next one there is set point at low. Set point at low outside air temperature is what is my design water temperature at that coldest outside air temperature. So in this case, I've got a 25-degree outside air temperature, and that 25-degree outside air temperature, I want a 180-degree set point. That's what you're achieving. So when it hits 25, I've got 180. That's what you're calculating. Now, the problem is that curve continues to calculate. So this is saying at 25 degrees outside air, I want 180. Well, what happens if it goes to 20 degrees? Well, guess what? That curve continues to calculate up. Right? The control will continue to calculate that set point up. That's where your system heating set point comes into play at. So if I look at this, that's where this thing comes into play over here, the system heating set point. That's got to be the top end of the curve. So let's say I want no hotter than 180 going to my system. Well, there you go. That becomes 180. So let's say maybe my design outside air temperature at 25 was only 160. Okay, cool. So at 25, it's 160. When it's 0, all right, it might be 180, but 180 becomes the top end of the curve. So that's where that set point temperature comes into play to limit the curve, because the curve will continue to calculate as it gets colder. All right. Now, the fourth parameter is set point at high. So what is my starting water temperature? So when I'm at my highest outside air temperature, what's my starting water temperature? Now, you're dealing with a condensing boiler. So what do we want it to do? We want it to condense. How do we get it to condense? We run low water temperatures to it. So the colder the water we've got coming back to this unit, the better. So that means I really want to start running lower temperatures. I don't want to be running 180 all the time. I want to run a low temperature. So typically I want to run less than 130. I want to run 120, 110, 100. I want to run lower temperatures. So I need to basically start at a low temperature. Now, the default as it leaves the factory is at 70 degrees outside air temperature, you will have a 70-degree set point. That's going to be the two default numbers. At 25-degree outside air temperature, you will have a 180-degree set point. Those are the two default numbers there. So that kind of sets up your default curve. What you need in your area is totally up to you. Again, I'm sitting here in Lebanon, Tennessee. I have no idea what your curve needs to be. Now, different reps throughout the country will have their own set of parameters that they use for the outdoor reset. Vimco may be that way. I'm not for sure if they have their own set of curves, set of parameters that they would recommend using in your area. And that's something you can check with them on to say, hey, do you have a set of numbers that would work here? And they may be able to offer that to you. Again, like I said, I know other reps do, and Vimco may be like that as well. So you just check with those guys, right? But those are your 4 numbers that you've got to program in, right? And that sets up your reset curve. Right. And we can do that for 1, 2, and 3. Remember, all 3 of them have their own reset curves. All right. Now, the next 2 there are outdoor shutdown and outdoor diff. All right. So at what outside air temperature do I no longer need space heating? All right. You're in the warm weather shutdown. As it leaves the factory, that's 70 degrees. So when it hits 70 degrees outside air, the control's going to say you need no more space heating. We're going to shut the space heating off. No matter if the thermostats are calling or not, you're not going to run. That's what's going to happen. That does not affect your indirect. Your indirect, if you're doing indirect water heating, that's totally separate. It's going to run during the warm weather shutdown. Not a big deal. But this just shuts off your space heating when you're in shutdown temperature. Right? Outdoor 1 diff. How many degrees does it need to drop outside before it would respond to a call for heat? As it leaves the factory, that number is going to be 10 degrees. Right? So if it drops 10 degrees below 70, it's going to initiate a call. It's going to say, hey, you could respond to a call for heat if you have one at that point. If you're doing reheat or dehumidification, that shutdown number might be 100 degrees or higher, right? Depending upon where you're at if you're doing dehumidification. So you'll crank that number up. So it depends upon where you're at. What is the hottest outside air temperature we need space heating for? That's what that's going to be, okay? Again, if you look at the curve, like I said, that set point number there, at 125, that is basically programming that. Now, Lochinvar U is our online training platform. On Lochinvar U, I have an outdoor reset calculator. So if you want to play with outdoor reset curves, you want to see what different numbers are going to get you, go to the website, www.lochinvaru.com. go under the tools section and you will see what's referred to as calculators. And you will find an outdoor reset calculator. There's several calculators there for outdoor reset, primary, secondary piping, expansion tank, all kinds of different things there. If you want to play with an outdoor reset curve and you want to see what it's going to do, go there and play with those numbers. And it will basically calculate what your curve is going to be. So it's very helpful if you want to see what's going on with it. All right. Let's see here next. Again, we got the outdoor one low, high, set point. We got all that. We're good to go there. You got the same thing for 2 and 3. Now, you notice that there's also a parameter called shift here. If I go back to one, go back here to one, you see outdoor 1 shift, 2 shift, 3 shift. All right. As it leaves the factory, that's set at 0. If you put a number there, it becomes active. So if I go back here, I see shift at 10. What that means is it's shifting your set point 10 degrees. So it's going to look at your 4 parameters. It's going to calculate what your set point should be. And then it's going to look at this number. And if you've got a number there, it's shifting the set point that many degrees. And you can go high, you can go positive or negative. You want to put it, if you put a negative 10 there, it would subtract 10 degrees from your set point. Most people never use that parameter. And the reason for that is because you're using that as a hedge. You don't know what your curve needs to be, so we're just going to add a few extra degrees there because I don't want to get that phone call from the owner going, hey, I'm cold, and you've got to go reset the curve. So they're just putting a few extra degrees in there to prevent that from happening. But most people will typically leave it at 0. But if you put something there, it will start adding to the number, and that's all it's going to be, all right? And then down at the very, very bottom of that list, you're going to have what's called boost temperature. If you put a number there, then you'll see what's called boost time pop up. Some people love this parameter, some people hate it. I fall into the latter category. Primarily because what the feature wants the heater to do is to cycle off. And again, that's kind of the last thing I want the heater to do is to cycle off. So generally we will avoid that one in most cases. So I'm going to leave that one alone, but if someone wants to ask more detail about it, if they want to use it, let me know and I'll get into that discussion. But otherwise, I'm going to leave that one alone because a lot of people will. All right. So next set of parameters, anti-cycling. So here's my next level of defense if I want to minimize cycling. So anti-cycle time. Once the unit cycles off, it records the inlet temperature and it starts this timer. And you'll see this pop up in the display and say anti-cycling. That means the heater cannot respond to a call for heat during this time frame. So for the next minute, you can't respond to a call for heat. All right. Now, if you want to set that at 5 minutes, 6 minutes, 10 minutes, you can crank that number up and the heater will stay off. It will not respond to another call for heat during that time frame, unless this anti-cycle differential comes in. So the control records the inlet temperature when the unit cycles off and it starts the anti-cycle time. All right. If you get a call for heat during this anti-cycling time and your inlet temperature drops this many degrees in the differential parameter, let's say 10, it's going to say, hey, your inlet temperature is dropping too fast. You need to come back on and respond. And it's going to override that and it's going to bring the heater on. So if your inlet temperature was say 120 when it cycled off, if it drops 10 degrees down to 110 and you've got a call for heat, it's going to come back on. It's going to override the anti-cycle time. So again, just another level. Again, if I want to spread those run times out, how long it's going to stay off, then the longer it stays off means the longer it's going to take to get it back to set point. So that increases your run time. So again, minimizing cycling. Your next one there is what's called ramp delay. So ramp delay, some people call this step modulation. If you enable this feature, if you turn it on, because right now it's disabled as it leaves the factory, but if you turn this on, you'll get these settings that you got to program. And what you're going to have is 6 individually timed steps that you got to program. So you can set the how long and for what the firing rate is going to be. So what that means is for step 1, for the first 2 minutes of operation, you will not go above 20% of rate. I can modulate down. I can go down to 10, which is the minimum, but you can't go above 20. All right. Then we go to the next step. Let's say the next step is 2 minutes at 40%. That means for the next 2 minutes of operation, you can't go above 40%. So again, it's just limiting your firing rate. And what you're trying to achieve is that the unit would meet its set point, meet its demand, and start modulating down before you got to 100%, right? What during this time frame. So you're hoping that you don't need to get to 100%. You're hoping that maybe a lower firing rate will get us to where we need to be, right? Because typically that 100% firing rate I only need on the coldest day. Well, how often is the coldest day? Not frequently. So the rest of the time, I don't need that much. So I can limit the firing rate for this. So again, you've got 6 individually timed steps that we can program in here. So you got step 1, step 2, step 3, and you can program them however you wish. All right. But here's the kicker. You know, I want to be down here operating most of the time. So that's why I want these longer run times at lower firing rates down here. But when we get to the back end of this, if you know you need 100% of rate, that last step has to be set at 100%. If you set this last step, let's say at 50, once it got there, that's all you will get. It will not go above 50%. All right. So if you know that the boiler is grossly oversized, and not that that ever happens, but if it was grossly oversized, say by 50%, you can set all those levels at 50%. The boiler will never go above it during a space heating demand. Again, indirect water heating, totally separate thing. This is space heating only. So if you set them all at 50, it'll never go above 50%. Just a quick, easy way of derating the boiler, right? So use this. A lot of people, and I know guys that will turn this on every job, and they will use ramp delay on every job. And I see the benefit for it, right? You just got to figure out what my numbers are. And again, if you call the factory and go, hey, what number should I set these at? I don't know. I don't know your job. I didn't design your job. You're going to have to play with it a little bit to figure out where you get the best performance at, right? Where it's going to perform best for that job. Yeah, I give you some default numbers. I think they're like 2 minutes. And it goes from like 20, 40, 60, 80, 100. It goes kind of like that. But again, does that work for you? Again, it's adjustable. Take advantage of that adjustment, okay? Now, the next one's modulation factor, and that's a relatively new parameter, so that got added as well. And I might have you go, ramp delay is your silver bullet. That will fix short cycling, period. I know that will fix your short cycling. But maybe before we go that far, maybe we use the modulation factor. Like I said, this is a little bit newer. So the modulation factor is just controlling how aggressive the control is. What I mean by that is how quickly is it going to ramp to 100%, right? So if I leave the control at its most aggressive, at 100% aggressiveness, that means it's going to respond the fastest. It's going to get you to 100% quickly. If I start backing that aggressiveness down, it just slows the reaction time of the control. That means it's just going to take longer to get you to 100%. So it's kind of like ramp delay without setting the levels, right? Now, the farther you are away from set point, the quicker it still will respond, right? So if my set point was 150 and my water temperature was 60, even though I might set that modulation factor at 40, it's going to ramp you up to 100% pretty quick because I'm way off set point. So it's just looking at these different factors to control how quickly I'm modulating up. So again, maybe before I go ramp delay and go, with the sledgehammer, maybe I use the modulation factor and back off that aggressiveness a little bit first and see what happens. Instead of 100%, maybe I make it 60, maybe 50, maybe 40. All right, limit that fire, limit that that aggressiveness of the control. And that's what you're doing with the modulation factor. A very, very nice feature that was added to the control. All right. So again, we'll stop here for a second. Has anybody got any questions? Going once, going twice. Nope. All right, cool. Let's talk a little bit about control modes. So when you kick into control modes, first thing you see there is how are you controlling it? Which sensor are you using? As it leaves the factory, it's the outlet sensor. And that's what I would prefer you to use. Would just be use the outlet sensor. You can select inlet if you want, but you're generally not going to get as good as control. So use the outlet. And if you got a choice, put a system sensor on it. Like I said, single heater applications, you don't need it. The outlet will work perfectly fine, but I just like using the system sensor. If you're doing a cascade, you don't have a choice. You got to use a system sensor, okay? So speaking of cascade, you can connect up to 8 units together off of a single boiler. Each unit has its own built-in sequencing capability, so it can control up to 8 units total in a cascade. Now, when we do a cascade, we have to do some programming on every heater. We got to tell it where it's at within the cascade, what we call the address of the cascade, right? So you have the cascade address of 0 through 7. The boiler that you designate with the cascade address of 0 is the sequencer. It's what we call the leader of the cascade, right? Then you're going to have what's called members 1 through 7. All right. So if I change that cascade address to 0 on a unit, it becomes the controlling unit. It becomes the leader of that cascade. So that means everything I want gets tied to that leader. So your system sensor comes only to the leader. So it doesn't need to go to all the other heaters. It only needs to go to the leader. It goes to the leader. Your outdoor reset sensor goes to the leader. Your enable input goes to the leader. Everything that you're controlling the cascade with goes to the leader. All right. And the leader is telling everything else when to come on, when to go off. That's what it's doing. Okay. It's the sequencer. Now, you have rotation. If all the units in the cascade are the same size, you're going to have a rotation. Everybody gets hung up on the term leader and they think leader means it's going to be first on every time. That's not the case. The leader just means it's a sequencer. The boiler that starts first, the unit that comes on first, rotates every 24 hours if they're the same size. We will allow you to mix and match sizes. If you want to take a 150 and an 80 and put them together, you can do that. You can mix and match however you wish. But when you mix and match sizes, the smallest boiler will always come on first no matter what. All right? Because why bring on a bigger boiler if the smaller one will do it? So the smaller units will always come on first and it would work up in size at that point. So that's a little bit of the cascade. So that's the unit starting first, how it works. All right. So the boiler that we designated as leader, we got to do some more programming with. So you see max cascade set point. All right. That is basically a limit that's going to be fed to every unit in the cascade. And it says, hey, if your outlet temperature hits this number, regardless of what I'm telling you to do, force your modulation down. All right. That means you're getting too hot. You need to shut off. You need to cycle down a little bit. The leader has no idea what the water temperature is at the other heaters. It only knows what the system temperature is. So it's going to feed this number out to the members as basically it's acting as a limit. And it just says, hey, if your outlet temperature hits this number, modulate. Regardless of what I'm telling you, modulate. So with that max cascade set point, you've also got an offset. You've also got a differential that applies to the cascade. This is replacing your system offset and differential. All right, so remember your set points that you programmed up earlier, and each one of those set points had an offset and a differential. This replaces that number. All right, so whatever you set those for, that's what these need to be set for on the leader to control the cascade. Then you've got cascade type, and you got lead lag, and you got efficiency optimization. You got two choices there, and I'm trying to think here if I've got that slide in here. Hang on for a second. I'm gonna scroll through my slides here real quickly. No, I don't have that one. So we're going to stop right here. So lead lag, you got two choices for cascade type. LL, lead lag. All right. Your other choice is what's called EFF, or efficiency optimized. That just means how you're controlling the cascade. All right. For lead lag, that basically means bring on the fewest number of boilers possible to meet your demand. So as an example, you've got 3 units in the cascade. That means you're going to bring one unit on first. It's got to get to 100% before you bring on the next unit. That unit's got to get to 100% before you bring on the next unit. And then as you start modulating or start meeting your demand, that last boiler that came on is going to be the first one that goes off. So it's going to modulate down first, cycle off, and the next one modulates down, cycles off, then the first one shuts down. So it's always a first on, last off arrangement. All right. So that's lead lag, bringing on the fewest number of boilers. All right. Your other choice is efficiency optimized. That means bring on as many boilers as possible. So again, same scenario. You got 3 units there. First unit comes on. Once it reaches a certain level, it says, hey, I can divide this and bring on a second unit. Okay, that division number happens to be 90%. So when that first unit hits 90, it's going to bring the other heater on, and the two are going to divide, and it's going to go 45 and 45. If they both modulate up and hit 90 again, and I've got a third unit, well, 90 and 90 is 180. I'll divide 180 by 3, and you get 60. So that's 60, 60, 60. All right. Every time you hit 90 across the board and you've got another unit, you're just dividing it by that extra number, and that's where your modulation is going to be at. So now you bring on all three, you get all three heaters running, they're all gonna modulate up and down together at the same rate. Once they hit a certain level, and what we call the trigger off point is 15%. When they all hit 15%, that last one shuts off, the others modulate up, and you repeat the process. So you get to a first on, last off arrangement. Now, again, that's your choice, which way you wish to control it. Some people prefer the efficiency optimized, some people prefer the lead lag. I fall into that category. I prefer the lead lag algorithm. I think that works a little bit better. But some people prefer the efficiency optimized. Again, totally up to you as far as which option you choose there, as far as which one you want to do it. That's totally up to you as far as how you wish to control that one, right? Now I want to show this slide here. This is my low voltage terminal board. So this is looking at the leader. So this is showing you your outdoor sensor, your tank sensor, if you're using indirect water system supply sensor, which has to be connected in the cascade, and then your cascade terminals. And you're just going to wire these in a daisy chain fashion. So when you look at this, you got two shielded terminals. Those are basically that's a ground terminal. You can use either one of those. It doesn't really matter. But then you got the communication terminals. And it's A to B. So when you wire this up, it goes in a daisy chain fashion, A to A to A, B to B to B, right? The addressing can be in any order you want. I don't care. It can be in any order you want. So if you've got a bunch, if you say you got all 8 units sitting there, if you want to put the leader in the middle and then go evens and odds on either side, be my guest. Most people will generally start leader on one end and then go 1 through 7 the rest of the way down. But again, the leader knows where everything is at in the cascade based on the address, and it's going to control those units based on that address. So take that for what you will, address them any way you want, just realize the cascade is going to be controlled correctly, no matter how you address them, all right? So with that leader programming done, we're good. Now the leader is going to control everything based on that. Well, what about this alternate leader here? So you notice you see cascade address 1, you get an alternate leader. All right, well, what happens if my leader dies, right? If the leader board fails completely, well, then you lose the cascade. Now, if it just goes into a lockout, it can still work. If it goes into a high limit, it goes into a flame failure, whatever, it just bypasses itself in the cascade, just like it would any other unit. If any heater is locked out, the leader says, oh, I can't use you. I'm just going to go to the next one in line and bring it on. So it just bypasses it, right? But if something happens to the leader board, right, you turn the power off to that unit, the board smokes, it fries, whatever, you lose the cascade because there's no longer any sequencer there to control the cascade, right? But we've got a workaround. We can go to the unit that you address as number 1, cascade address 1, unit 1, leader or member 1. And we see that alternate leader. We make that yes. Well, guess what? It now becomes your leader. If we make that yes, it will now control the cascade because it's going to say, hey, I don't see any units setting out there. I don't see a leader setting out there. So if there's no leader, that means I'm in command. So if you don't want to have any interruption in operation, you make leader member 1 alternate leader. You check that yes. And if you want the same control, if you want that unit to operate exactly the way the leader did, whatever and however you program the leader, you got to duplicate here on member 1. So that means you got to bring a system sensor to member 1. It means you got to bring an outdoor sensor to member 1. Whatever you've connected to the leader, you have to duplicate on member 1. And that doesn't mean I'm running wires from the system sensor from the leader over to member. That means I need a separate system sensor. You can't run those wires over. That screws the resistance of the system of the sensor up, which throws off what the heater's doing, what it sees. So everything has to be individual at that point. So its own system sensor, its own outdoor sensor, if you want the same functionality as what you had with the leader. So, but just another way to bring the unit on. Now, once the leader comes back, say if somebody just turned the power off on the leader, they turn the power back on. Oh, members going to say, oh, you're back. All right, I'm going to get out of the way. Leader, you take over again. And that's how it's going to work. Okay. So real quickly, I'm going to stop there. Anybody got any questions on that? Like I said, I went through that pretty quick. Does anybody have any questions on that cascade operation? All right, I see nothing yet so far on the chat, so I'm gonna move on. But if you got a question, make sure you get that typed in, and I'll get that answer for you. I'll come back and answer that for you, okay? All right, so you got a couple parameters you do have to program on the leader, besides the cascade type. You got some minimum on-off times. That minimum next on time, hey, that's a great parameter. That puts a delay between units. So again, if you've got a multiple unit cascade, and again, you don't want to slam these heaters on all at once. You want to spread it out. Hey, maybe one heater, if it runs a little bit longer, will catch the load. Instead of 1 minute, maybe you put 5 minutes there. Maybe you put 10 minutes there. You let one unit run a little bit longer before you bring the other units on at that point. Then you've also got what's called boiler sizes. So let's say I had a bank of older night products, right? First generation night products, all right? And one of those fails and I want to replace it with a new unit, all right? Well, the new heater will have no idea what those older units are, all right? So when I do that, I've got to come here to boiler sizes and I've got to tell it what those other heaters are setting out there. So that means I got to go into the cascade here. It's going to say, what type is this? Is it a condensing unit? And what's the input? Now, I can do that with older night products. I could actually hook up a night product to an older power fin product. If I want to do a front-end loaded system, do a high efficiency and mid-range efficiency product, I can do that. So I've got to tell it what address it's at in the cascade. I've got to tell it, is it a condensing or a non-condensing product? And what is the input of that product? So that way now my new heater knows how to control that system. So again, if you're taking a system with old heaters and you're adding a new one to it, make sure the new unit is the leader so you have this functionality. Otherwise, it's not going to work correctly, right? It's not to say that it won't work, it just won't work correctly. That would be the problem, okay? So make sure you input that information in. All right. Then you've also got BMS. And for us, BMS in this case is going to relate to 0 to 10 volt DC operation, right? So if you make that active, then I've got to tell the control, what are we doing with that 0 to 10 volt signal? Are we controlling set point or are we controlling modulation? Control set point. Do not, yes, I give you the option to control modulation, though I'd rather you not control modulation. All right. I'd rather you control the set point. Tell me what temperature you want me to go to. We spend a lot of time and money in my control, and I think I can control my boiler better than you can. Okay, or Tecmar or whoever else you're wanting to use, right? I can control the firing rate better. You tell me what temperature you want, allow me to drive the firing rate to that. So we're going to select set point. Then I got to tell it what's my set point ranges, right? What's my set point at min volts? What's my set point at max volts? And then I got to tell it, what is the min and max voltage? 210, 19, 34. What are the numbers? With the voltage, make sure they're spread out, right? 2 and 10, 1 and 9, 1 and 10, whatever the number is. If you set it, and I've seen guys do this. I've seen guys set it like min volts at 4, max volts at 5. You don't have a curve then at that point, all right? It's flat. So there is no reset curve. So don't do that. Spread those numbers out as far as you can, okay? So you got that. Our modulation, again, we're just going to ignore modulation. You also have the ability to use that 0 to 10 volt DC signal to initiate your call for heat, right? So I can either set that to active or inactive, right? If I set it to inactive, that basically means I'm using, and I know this is kind of confusing, if I set this to inactive, it's going to be looking at that voltage to initiate that start-stop signal. If you set BMS T-stat to active, and again, I know this is counterintuitive, that means I'm using a normal stat tied across the thermostat contacts to initiate the call for heat, right? As it leaves the factory, it's set for active, right? But if you want to use that signal, cool, make it inactive. Tell me how many volts it's going to take to initiate that call for heat and how many volts it has to drop to turn that call for heat off. Again, your differential. That's what you're setting with this one, right? So you got the choice there if you wish to use that signal to do that with or not. You've also got the ability to do Modbus BACnet to do a full-blown integration. That would require the addition of a BACnet Modbus card. So that would be optional. But if you want to do full-blown integration, you can do that. If you do full-blown integration, you can control, you can either just monitor the unit, in which case then you don't worry about this parameter, or you could feed me information. If you're going to feed me information, you've got to make this active. You got to tell the control, hey, look at your Modbus card to get the information from. So you'll make that active and then you'll program in your timeout. And your timeout basically just means, hey, I'm looking for information from the system every 10 seconds. You can set that to 2 minutes if you want. Do not set it to 2 minutes. The longer you set that, the longer of a delay you've got there. So that means it's only looking for information every 2 minutes. A lot can change. A lot can change in your system in 2 minutes. So you want to set that number as low as possible. So again, so at least the factory, it's 10 seconds. If you want to set it to 5 seconds, that's 5 seconds. But it's saying I need to see information this many seconds, right? If I don't see information within 10 seconds, I'm going to kick out and go back to normal operation. I'll ignore the Modbus. I'll go back. So again, you got to know what your cycle time is going to be in your system if you're going to do the Modbus. And that's where the integrator will come into play at, and he's going to program that information up. Okay. Your next set of parameters after that is going to be your service notification. So you've got must time cycle. You hit any one of those counters, you're going to get your screen's going to turn yellow. It's going to say, hey, maintenance required. Once it does that, then you can come in here and hit reset service reminder, and that just resets the counters. You've also got the ability to program in, there's that reset reminder, but you also have the ability to come in and program a name on the phone number. If you want to program in a name and a phone number, great, do so. So that means when it pops up for this service due or its maintenance required screen, it would show your information. Whatever you do, don't put Lochinvar 1-800-722-2101. Don't do that. All right, that's our 800 number. If you put that number in there and somebody calls me, I am not coming to service your boiler. All right, this is for you. Put that information in there so you don't put stickers all over my cabinet. All right, so put that in there and that will pop up whenever you have service due or anytime it goes into a lockout. That information will pop up as well when it goes into a lockout. Okay. Your next set of parameters are USB. On the front of the heater, you have the ability to plug in a flash drive, and you can download or upload program files from the flash drive to your control. So what that means is, hey, if I've got a set way of programming up all my 80s, my snow melt 80s, all right, and I'm going to program them up the same exact way every time, I can program that on one heater, download that program file to the flash drive, and then I can walk in on any other heater, plug the flash drive in, and download those parameters. So when you plug in a flash drive and you select that parameter, it's going to look for a folder on that drive labeled Lochinvar. That's what it's looking for. So like in this case, it says no Lochinvar directory. It's not finding a folder on that flash drive. So it's going to say create or try another. All right, cool. Hit create. And that's going to create a file or a folder on that flash drive labeled Lochinvar. And that's where all these files are going to be stored. All right, so if there's nothing there, it's going to say no file found. But there is something, it will show you the file. And the file will be listed by the date and time that the file was created. You can change this to whatever you want. You can adjust that. So you don't have to be stuck with the date and time. So if you want to call that snow melt 80, all right, baseboard 150, whatever the number, whatever you want to call it, you can change that. So once you have it changed whatever you want, and you have this saved on your flash drive, if you go to another job and you plug it in, all right, and you say, hey, I selected that one, select it, load parameters from that file, you're going to hit yes or no, and away you go. It's going to download all those parameters into that. The only thing it cannot load is date and time. That is the only thing that you would have to do manually on a heater, is manually program the date and time. But everything else will be programmed from the flash drive. So it's just kind of a cool thing, neat thing to have. Again, if say maybe you program up your boiler, you can download those parameters on a flash drive, leave them on the job somewhere. So if something happens and the control craps out, right? Hey, I've got a flash drive of the backup set of parameters. Or you come in a little bit later and you see the homeowner or somebody else has come in and screwed with all your parameters and it's all jacked up. Hey, you've got a backup set in there. You can plug them in, reprogram it back to the way you want to do that. So it's kind of a nice thing to have as a backup. So you've got that ability, right? Now, once you program up all of your changes, all right, then you're going to hit this button called home, all right? Now, as you're going through and you're making a change, right? You make a change to a parameter, you're hitting save. There's a save button, you hit save, you hit save. You're hitting save as you go through and you're changing parameters. But none of those parameters are going to be downloaded into your control until you hit this button, home. All right. Now, until you hit home, nothing gets dumped into the control. That's what's got to happen first. So you're getting save as you go through it, but home is the last thing you've got to hit. So whether you made one change or whether you made 100 changes, all right, you've got to hit home last to download the parameters into the control. And once you do that, you're good. Okay. So now we've got all the parameters programmed the way we wanted it. And we're cool. Now, as I mentioned earlier, there are a few things that you can access without a set point or without a password, primarily your temperature settings. So access those right from the front of the heater. Right? So this will be from your display. There's your flash drive connection. Right? Here's your select buttons, left and right key. Right? Here's your navigation dial right in the center. All you've got to do to access these set points is, as the display says, press that dial in. Right? So you press that dial in, and that brings up your set points, 1, 2, and 3, and your DHW set point. So again, anybody can walk in and adjust these things. You want to prevent that from happening? That's where that min and max set point parameter comes into play at. We can adjust those, prevent that from happening. So if I want to select set point 1, get the little pointer here, you're going to highlight that, press the dial in. When you press that dial in, that number will start to flash. Anytime you see a flashing number, that means it's an adjust state. It means you can adjust it at that point. So that means I can take that dial and adjust that number to whatever I want. Once you get it adjusted to what you want, you got to remember, hit save over here, right? Hit that save button to program that in. Hit save, right? Now, once we get them all done, you hit home here to take it back out and download all those parameters that you've just changed. Now, the other thing you can access is your high limits. So that's over here on the left side. You hit limits. You got an auto and you got a manual. So if you have an inspector, he wants to test the high limit function, this is where he's got to come to. There are no gray dials, there are no red push buttons. He has to come here to adjust this. So you're going to select which high limit you wish. All right. Select the manual reset high limit. That's set at 210. As it leaves the factory, your auto reset is set at 200 maximum, manual set at 210 maximum. The reason it's set at 210, stainless steel heat exchangers per standard can have no higher than 210 degree outlet water temperature, period. So that manual reset is setting there at 210. I don't want to be anywhere near that number. So the control will shut you off at 195 regardless. All right. So you hopefully will never hit that manual reset high limit, but if someone who wants to test it, or if they crank it down, this is where you're going to do it at. So your inspector comes here, he highlights that. He pushes the dial in, that number will start to flash. You can crank that down to whatever you want, hit save, and then you got to hit home. Remember, you always got to hit home to program it into the control, right? If you don't hit home, it doesn't program into the control. So if he's testing the manual reset, it's going to take several steps. Those steps, there's a little sticker on the inside cabinet that describes how you test the manual reset function. But this is where you're going to do it at. And it does not require a password or passcode to get into it. All right. So this is the nights. Like I said, I went through that pretty quickly. There are a lot of other parameters that we didn't talk about, but I kind of hit the key point ones, right? So I kind of went through that pretty fast. So I'm going to wait here just a moment. I know we're coming up on 12 and I've got just a couple more things to go through and we'll be done, I promise. Then we'll see, does anybody have any questions? You've been very, very, very quiet. So again, I don't know if that's a good thing or a bad thing, but you've been very quiet. So check the box. Got nothing yet. All right. So again, if you got something, type it in, let me know. All right. So while we're doing that, I'm going to scroll over here to the Noble. All right. So the Noble, instead of using the dial, uses basically a push button navigation, right? So you got left, right, up, down arrow keys. You got a reset button there. What you see on the display is very intuitive. I will have to mention what you see, what the verbiage that you'll see on the screen is very, very intuitive. Makes it easy to follow. Just like the night, when first time you power this thing up, you're going to go through the setup wizard, right? So I can either use the up and down arrow key to change the parameter, right arrow key to go to the next parameter, and you can see we can go through date and time, space heating set point, DHW set point, outdoor reset, temperature, rate limiting, so you got all those things. Or if I just don't want to screw with it, just hit the left arrow key and you exit, all right, when you get done with it. So if you do go through the setup wizard, when you get to the very last parameter, it's just going to say finished, all right? So basically hit that right arrow key and you hit finished, and it will save automatically at that point. So you'll be done. So if you go back here, if you notice, let me go back here, this one says save exit. Say maybe I make a change to date and time, but I don't want to screw with the rest of them. Hit that left arrow key. That will save that parameter, and it'll just exit out from there. If you go through all of them, right, you hit all the parameters in that setup wizard, the last one's going to say finished. Hit the right arrow key, and it just automatically downloads for you right off the bat. Okay. If you want to get into the parameters, hit that menu key. That's going to bring up your passcode, and guess what? It's still 5309, doesn't change. Enter that in, going from left to right, 5309. Hit next, and that's going to bring in your adjustable parameters. Here's the thing, pretty much the adjustable parameters that you have on the Noble boiler would be the same parameters that you have on the Knight. Okay, just fewer of them, right? I don't have 3 different temperature inputs. You've only got one on the Noble. You don't have BMS. You don't have 0 tempo DC operation on this unit. So you do have, it's kind of a, again, smart system light. You don't have all the feature sets. You have the key things, outdoor reset, cascade, set points, offset differential. So you have some key things, but you don't have everything. If you want all those cool features, bells and whistles, you go with the Knight, right? Now, your combi model has one other little set of parameters, which is unique to the combi. That's called the advanced combi settings. So there's 2 parameters under that, and that's going to be your DHW respond time. Right, first one there. DHW respond time, all that means is when the unit cycles off, you go through what's called a post purge. All right. The post purge is roughly 30 seconds. Right. That just means it keeps the fan running for 30 seconds, blows out any residual flue gases from the combustion chamber, then it shuts down. Well, whenever you get a call for heat, you have to go through what's called a pre-purge time. So you go through pre-purge, which is about 20 to 30 seconds before you fire up the burner. Right. So what this DHW respond time does is it basically, when you satisfy demand, it keeps the fan running longer after that post-purge time. So that way, let's say if you got somebody who's using hot water and they turn the faucet on, which kicks the heater on, runs it for a little bit, shuts the faucet off, kicks the heater off, but then turns the faucet back on again. Well, I don't have to go back through that pre-purge time, right? I want the fire right back up so I get that quick response time. That's what this is. So I can run that fan longer. And the max time on this, I believe, is 5 minutes. So I can run that post-purge time longer. So that way, if I get that next DHW call, instead of having to go through pre-purge over again without the unit running, I can immediately fire the burner up. So again, it just allows that burner to respond faster. So that means you get quicker hot water is what you're dealing with here, right? So that's what that respond time is doing, is just increasing that post-purge time on the fan. So that's one. The second one is what's called preheat enabled. And as it leaves the factory, this is turned off. So you do have to turn this one on if you wish to use it. All right. What this is going to do is it's trying to keep basically your boiler heat exchanger and your combi heat exchanger hot, right? So if I enable this, it will basically, if the heater's setting off, if the temperature starts to drop in that combi block, it starts up that pump. It will have, if you're not doing space heating, this is, right? If you're not doing space heating, so if the heater's just setting off, there's no call for heat on anything. If that temperature starts to drop, it's going to have the default position is always in the domestic mode. So it means everything coming from the boiler heat exchanger is going to go through that braze plate. So that means if that braze plate temperature starts to drop, it's going to kick the pump on, which is going to circulate fluid from the boiler heat exchanger into the combi heat exchanger to try to heat it up. If the boiler heat exchanger starts to cool off, guess what? It will actually fire the boiler at its minimum rate just to heat up that primary heat exchanger, heat up that boiler heat exchanger to make sure the combi heat exchanger is staying hot. So that way, when someone opens up a faucet, I don't have to go through pre-purge. I don't have to go through all that heat up time if that thing's been off for an hour. to get hot water out to the faucets. I've got hot water already established at that point. But if you use this, that also means I'm going to be using more electricity. I'm going to be using more gas, because there are going to be times when the thing comes on when there's no demand, but it's coming on to heat up that heat exchanger. So again, you have the trade-off there. So you got to keep in mind, do I wish to use this? What's more important, right? The comfort, or how quickly I'm getting hot water, or the gas savings, right? That's the gas and electrical. So that's going to be the deciding factor at that point. But you've got to have that decision made to, am I going to activate this feature or not? Okay. So those are the two parameters that would be different on the combi than you would have on the normal boiler or the Knights. The Knights will not have, obviously, this feature. So this will only be on the combi product, right? But once you program everything, just like the Knights, you got to hit save home. And once you hit save home, it downloads all the changes that you just made, get dumped into that control. Right now, they're just saved in the display. When you hit save home, it dumps it into the control, and now the control is programmed the way you set it up. All right. Set points, again, just like the Knights, you can access your set points without a password. So hit that left arrow key. That will bring up your set point screen. Again, your outdoor reset parameters, cold day temperatures, your temperature Fahrenheits, high limits, auto, as well as manual reset. So again, all those can be accessed without a passcode. So you can program all that stuff in. All right. Now, hit save exits, and you've saved all your parameters. All right, so it is 12:01. I almost got finished by 12 o'clock. And like I said, that was a real flash run through of those parameters. Like I said, normally when we do a class here at this factory, or do an in-person class, typically that's, minimum 2 hours, possibly 3 hours to go through those control parameters. And I know it's hard doing this over Zoom. It's hard to ask questions and things of that nature. But again, if you got anything, type them in. But I am pretty much done. So I'm gonna kind of break it here. I'm gonna stay online for a little bit. So if anybody's got questions, they can type those in, or if they want to unmute and ask, they can do that. But unless Gail or any of the guys at Vimco have anything they want to add, I'll open it up to them if they want to add anything. You guys are free to go. So Gail or guys at Vimco, if you got anything you want to add, chime in.
Well, I just want to say thank you to everybody for jumping on today. If you have any questions, please either ask him here, or if you have anything later, you can reach out to Nathan or myself on anything that we covered today. But again, thank you everybody for jumping on. We greatly appreciate it.
Yeah, also on behalf of MCO, want to say thanks to everybody too. I know that there's times where we have our challenges out in the field, and all of those that are attending this are trying to get better at ways to improve overall installations, owners experience, their own experience for themselves from an installation perspective. And I just want to again say thanks for the loyalty and the commitments. Appreciate it.
All right. Well, like I said, I'm gonna hang out here for a few minutes, guys. So, but otherwise, you're free to go. Appreciate your time. Hopefully you learned a little bit. Hopefully you got some questions. If you had questions answered, you got those answered. But if there's anything, contact information there is on the screen. Basically, you can give us a call, Car Technical Services Group, or if you just want to send us an email in the training department, training@lochinvar.com, general email box. So if you got any questions, just send those along. We'll be more happy to try to answer those for you. Otherwise, we'll see you guys later.
Charles, nice job. Thank you.
Thank you, Nathan. For anybody that's listening, Hans here has asked a question. Is there a way to run the boiler pump without firing the boiler? Let's shutting the gas off and sending a call for heat to the boiler. Not really. The only way to run the boiler pump without firing the boiler, I'm sitting here trying to think the parameters. I don't think there's a way to do that because it's going to respond on a call for heat. The only way and because it's powered through there, that's not dry contacts. Unfortunately, no, there's not. So it's probably not the question, not the answer you're looking for, but there isn't a way unless you just hotwire the pump and run the pump continuous. That would be the only way. So that's probably not what you're looking for, but that's the only thing I can give you. Sorry. Thank you guys. Appreciate it.